Welcome to Module 9. Module 9 is going to contain a whole series of lessons that's going to help us set up an end-to-end user service within our Express API. The service is going to allow us to get a user, create a user, update a user, as well as delete a user. And we're going to go through all of this step by step and implement all the code that we need to make this happen. We're also going to go through a very particular pattern that we're going to set up in this instance of our Express API. In this first lesson of the module, we're just going to set up a user router and some additional work that we need to add to our API in order to prepare for this user service. In order to get started, let's just get our Docker containers up and running. At the moment, my containers are all stopped. And up until this point, we've been starting up the Docker containers with Docker Compose up. I wanted to start up the containers slightly differently within this module. The reason being is that I want to isolate the real-time logs of the API service. I'm not that interested in the MongoDB logs. I'm more interested in seeing the logs in our API service because that's going to be where we're working most of the time throughout the next series of lessons. All we need to do here to set this up is we can say Docker Compose up like we have been doing, and then we're just going to add the -t flag, and this is going to start our containers without any logs. So I'm going to hit enter there and wait for our containers to start up. Once you have that confirmation that your containers are up and running, now you can go ahead and run a new command here. We can say Docker Compose, and then we're going to say logs and then -f, and this is a short for --follow, and so we'll just use the short one here. So we'll say -f. The next parameter here is the name of the service of which the logs that you want to follow in real time, and in this case we want to run or follow those API logs. So I'm going to hit enter there. We've got our logs that are coming through in our terminal here, and this should update in real time. Now that we have our containers up and running, let's start writing some code in our Express API. The first change that I want to make is within the server.js file. I just want to add an additional configuration to our Express instance here. Now that we're setting up a more sophisticated set of endpoints in our API, I just want to make sure that we're using some middleware here that is available to us on Express. So I'm going to say app.use. Now we'll just use this express.json middleware, and we're just going to invoke it. And that's all we need to do to our server.js. So we're just going to go ahead and save that file. And this piece of middleware that we've referenced here, the express.json, is just going to allow us to pass incoming requests from our API as JSON payloads, and what it's going to do is convert that JSON into JavaScript objects, which will make it easier to work with downstream in the request handler. This particular configuration we set up, we're not passing any options in, and that just means that we're going to make use of the default settings. So that's pretty simple and easy. I think next up, let's start setting up the user router. We can head on over to our routes folder, and in here you can see that in our index.js we've got this pipeline that's going to set up all our routers, and we've just got the default routes that we've set up. We're going to create a set of routes for our user. To do this, this is going to be a multi-step process. I think the first thing let's do is let's go ahead to our config and enable these routes at the config level. So in the config.js file, in the root section, we can just create a new key here called user, and we'll enable this by setting that to true. Save your work, and we can head on back to our index.js file here. So in our routes pipeline here, what we want to do is go ahead and open up a new conditional block. We're just going to say config.routes.user. If that is enabled, we want to make use of the user routes, which we haven't set up at this point in time, but we'll just make a note of that there. And just to see if this is working, you can just do a quick console log. Say user routes enabled, and we do get confirmation in our terminal here that this configuration has been set up correctly. So let's just go ahead and remove all of that. So to wire this up now, we can just go ahead and create a new file, and we're going to call this user router.js, and in our user router we want to import Express. So we'll do import Express from the Express package. Then we'll just set up a constant here called user router, and this is going to be an instance of the Express router, so we'll just invoke that. And then the next thing, we need to set up our function that we're going to export here. So we'll say export const user routes, and that's going to be an arrow function that we set up that takes in a router, and these set of routes are going to make use of the user router that we've defined at the top of the file here, and we want to make any of these user endpoints available at the /user endpoint, and so we'll just pass that in as the first argument into the .use method here, and then that will need to take in a router, so we'll say user router, which now that we've set this up, and just pardon my mistake here, I said root.use, it should be router.use, so it should be a reference to this parameter that's being passed in. Let's just set up a simple get request handler here so that we can test if everything has been wired up correctly. So we can reference the user router and we'll use the get method here. And we're just going to want this to be available at the /user, but we want to make use of the syntax here where if it picks up that there's an ID that's passed in, we just want to pull that in as a parameter and then name it as _ID. So we'll say / _ID. Then we'll just set up a request handler. And we'll just put a console log in here. We'll say hitting the get user endpoint. And for now, let's just say res.send status. And then we'll give that a value of 200. And that's just to end the request response cycle. Hopefully we've set this up correctly without any mistakes. And so we can go back to our index.js file in the routes folder. And we can say import. And we'll import those user routes that we've just created. That'll be from our user router.js file. And then we can just go ahead and reference these user routes function. And we'll just pass in the router. And now that we've wired this up, let's go ahead and test that. In this module, we're going to be doing a lot of testing on our API. So instead of using the browser or the curl command, let's go ahead and make use of Postman to test this out. So we can make use of a tool called Postman. If you haven't got this on your computer, you can download it or even use the web version of this. However, you're very welcome to use a curl command or anything like that in your terminal. But just go ahead and download Postman if you want to follow along exactly with what I'm doing. It's quite self-explanatory to get the setup. But once you have got it set up, you can just go ahead and open up a new tab, and you can just set up a GET request. So you can choose any of the HTTP methods here, and then you can just input your localhost 3000 API/user. And then for your ID, I've just gone ahead and pre-populated this. But at this stage, you can really put in anything you want. There's no validation or whatever in our API. And so just to test it out, we can hit send here, and you'll see we get a 200 OK. And in our terminal, you'll see that we get this console saying hitting the get user endpoint. So that's just a quick sanity check for us to ensure that we've wired everything up correctly and that we know that our user routes can now be used for each one of our other API endpoints here. The last step here that I want to do is just go ahead and this code block that we've set up here already. And so we're just going to reuse this code for now because it acts as a nice skeleton for us. And so we want to have four endpoints here: a get, a create, a put, and a delete. So let's just go ahead and set this up real quick. We'll say user router.post. So that'll be our post method, and our post is not going to take in any parameters, so it'll just be available at the root here, which will be user, and that'll have a normal request and response. And we'll just say hitting the post user endpoint. Then we can go ahead and set up another code block, and this one is going to be for a put, and the put will also take in an ID as a parameter, so we can just leave it like that. We'll just update the console log, and the last one that we want to put in there is the delete, and this will also take in an ID, and then we'll just reference the delete method here. And once we've saved that, we can head on over to Postman. We can go ahead and just change this. Let's go ahead and test the put, because that'll take in an ID. We get back a 200 OK, and we see that our terminal saying hitting the put user endpoint. We can test the delete. You can see we're hitting the delete user endpoint. And to test the post, we just change the HTTP verb there to post, and we can just remove this parameter that we passed in there, and then we can just send it through like that, just as it is, and we'll get hitting the post user endpoint, and we get back a 200. We can go ahead and just clean up our code here a little bit. With all that work that we just did, we've successfully wired up a user router, and we've added it to our Express API. We also made that quick adjustment to make sure our API is passing the JSON payloads and converting them to JavaScript objects. We've scaffolded out our get, post, our put, and delete methods. And so let's take a short break here. In the next lesson, we're going to start adding a new element into our API to start working and getting these endpoints working in the correct manner. So I'll see you on over there. Cheers for now. Hello and welcome back. In the last lesson, we scaffolded out our user routes for our API. In this lesson, we're going to start taking it one step further. And so the whole idea with what we're trying to do here is each one of these endpoints that we create, we're going to need to be interacting with our Mongo database. So for the post request, we want to be able to save information from an incoming API request, and we want to save that within the MongoDB and persist that data. And then we can use the GET request then to retrieve that information via API. And so we need to start setting up and connecting these routes that we've just created and figuring out how we're going to connect them and save this data and retrieve it or update it, delete it from our MongoDB. Instead of connecting to the database and writing all the code and the logic to interact with the schemas in our router folder, we're going to just create 2 layers of abstraction here just to make our code a bit neater and just to separate the code and make it easier to maintain and read. And so we're going to introduce a new layer into our API, and this layer is going to be called services. So I'm going to go ahead at the root of our source folder. I'm going to create a new folder called services. And so this services folder can be used to create a group of service files for each one of the routers that we have. So we can just create a folder within the services file called user. And that's just going to house any files that we create that will be associated with the user router. And so we're going to go ahead and we're going to create a new file called service.userservice.js, and just take note of the uppercase here that I'm using. And that's just a convention I want to use in my Express API. And that's just going to denote that this user service is related to the schema that we'll set up at a later stage. The purpose of these service files is they're going to act as the intermediary between our router and the model layer, which will be the Mongo schema. And so we can create functions in the service file that will then house the code to interact with the Mongo schema. So to show you how this all works, let's just go ahead and start setting up this file in the way that we need to. We can say export constant, and then this will be user service. And this will just be an object that we export. And then on this object, we're just going to have a set of functions. And so for each one of the routes that we have, like get and create, we can have a function. So we can just define an arrow function here. And then as our API grows, we can just create functions for each one of the items that we need for get, update, delete, and create. So I'm just going to leave those as the update one as empty for now. But let's just go ahead and create a mock function here that we can use just to start wiring this up. So this is going to take in an argument with an ID. And then let's set up a console log here. And we'll say user service called. And then we'll just print out the ID that we get back, or that is passed through. And then for now, let's just return a JavaScript object. And then we'll say user ID, and that'll be the ID that comes through. We'll say name, and just put anything in there. That'll be, and then email, we can just say whatever email. This is all just placeholder stuff for now. And so the idea here is we can import this user service into our user root. So let's go ahead and do that in our user router. We can go ahead and import our user service. We'll say from, we want to go back one level and go into services / say user service.js file. And once we have imported that, then we can reference this user service object. Let's go ahead and do that here in our get. So the user service get function that we've just created takes in an ID. So we need to strip this ID off our request that's coming through on this get request. So let's say const ID equals request, and it'll be available on the parameters, and then we'll just reference the underscore ID. And so this reference that we've created here will directly correlate to the name of the parameter that we've named here in this string that we've set up earlier. So once we have the ID, let's just log that out. We'll say user ID, and we'll just print that out. And then we'll say const user equals user service. And then we'll reference that get method that we've just created, and then we'll pass through the ID. Then once we have that user, instead of saying send status, let's just send a res.status 200, and then send back a JSON object, and we'll just send through the user that we get back that we've set up. So I'm going to go ahead and hit save here. We can just flip over to Postman, and in Postman, let's just change this back to a get, and we're going to have pass through an ID here. And then I'm going to hit us send here, give us a bit more space. You'll see that we see in our console, we see hitting the get user endpoint. We see the ID that is related to the ID that we've passed through here, and then we can see that we get this user service called with this console log. And so in the user service, you can see that we successfully hitting this function body that we've created of this get method. And so at this stage, I think we validated that we've wired up our user service to our user router. And so this is just some dummy code for now, but eventually this is going to house the code that we're going to need in order to set up or interact with our MongoDB layer. So let's take a short break now. In the next lesson, we'll start working on the model layer. So I'll see you on over there. Cheers for now. We've set up our user routes. We've set up our user service. The next step is to implement the next kind of abstracted layer in our API. And so we're going to set up a dedicated models folder, which will hold a file that is related to each model that we create. So every kind of entity around a data object. So for example, we working with our user routes. And so we'll have a user model, which will contain a Mongoose schema that will be related to a user that gets saved into the database. And so we need to start setting this up in our API so that we have a place where we can write this code. So what we're going to do is in the root of our source folder, we're going to create a new folder. We're going to call this models. And then the first model we're going to create here is the user schema. I'll name this file userschema.js. And if you take a look at the Mongoose docs, you'll see that there's a whole section on schemas here, which you can go ahead and read. And basically everything in Mongoose revolves around the schema. And the schema that you create in code here is going to map to a MongoDB collection. So you can basically define the outline of what you want your data object to look like. And this is going to give us a way to, or Mongoose is going to give us a way then to interact and have a code representation of our data object, which will map directly to what is stored in MongoDB. So there's a lot of cool things that we can do with the schema that's available from Mongoose, and we'll test a few of these things out in our code as we go along. But for now, let's just set up the very basic schema that we're going to need to get this working. So the first thing we need to do is import Mongoose from the Mongoose package. Then once we've done that, we'll create a schema so we can just destructure this. So this is the syntax that is used from the Mongoose documentation. And so that'll be available to us from Mongoose. And once we have this schema, we can create an instance of the schema. So we'll say user schema. And this is going to be a new instance of schema. And this will take in an object, which we will create now. And this object is going to be just a JavaScript object that's going to outline what we want our user schema to look like. And if you take a look at the docs, it's quite simple. You kind of have this key value system here, where the key is what the data key that you want to create in your schema, and then the value will be whatever type that you want it to be. And so they have this shorthand syntax available to us, where instead of having an object with clearly defining what type you want, you can just reference the type that you want as a shorthand syntax. And you can go ahead, and the permitted schema types are string, number, date, buffer, boolean, mixed, object ID, array, decimal, 1 to 8, map, and UUID. So we can just make use of this shorthand, but we'll also use an example without the shorthand syntax. And so we'll start with that. We'll say property that we want on this user schema is a name. And so now we're using the longhand syntax here. And then the type that we want this to be is an object. And then we'll use this key here called default. And so we kind of clearly and explicitly defining what we want these object keys to be. This is the whole point of this default. So say default, we want an object with 2 keys. It's going to be first, which will be a string, and then last, which will also be of type string. And then that's all we need for the name. Next up, we will have an email, which will just be a string. And so over here, we're using that shorthand syntax. And then we're going to have a created key here, which I'm going to give this a value of number, and I want this to be a timestamp. And then we'll do the same for updated. This will also be a number. And so on each user that is stored in our database, we'll have a timestamp of when it was created. And when and if it is ever updated, we'll have a timestamp of that. And let's just go ahead and create some other properties here. We'll say active, which let's set this to a Boolean. So this will just be a true or false whether the user is active or not. We'll have a banned key here, and that's just going to be for like admin purposes if a user is banned or not. Then we'll set a locale, which will be of type string. The next two keys here are two properties that I want to create on every user object, and I'm going to give this an underscore because I want them to be internal properties. So I want them to be like admin only properties, and I'm just going to, everything that I use as an underscore, that's my way of knowing that those properties are only meant to be for like admin users and never meant to be sent back to the actual user. So this is going to be an object, and the last one here is tags, and I also want this to be an admin only property, and that's just going to be of type array. Mistake there. So that's what we want our user schema to look like. Once we've defined that, we can go ahead and just implement the last step here to get this working. And the last thing that we need to do is, if you take a look at the docs, the last thing is you actually need to create the model. And so there's this syntax that you need to use, and you need to say mongoose.model, and then you pass in a string, which would be the name of the model, and then you pass in the schema that you've just defined. So what we can do is we can go ahead and export this mongoose model, and we'll say export const user, and then we'll say mongoose.model. We'll call this user, and then we'll just pass in the user schema. Just take note of the convention that I'm choosing to use here. For anything model related, I'm choosing to give it an uppercase. So I'm saying uppercase user, and that's just a convention that I want to use within our Express API. Now that we have the schema defined, we can go back to our user service file. And as I mentioned before, this file is intended to act as an intermediary between our router and our model layer. And so at the top of this file, we can go ahead and import our newly created user model. And so we'll say import user, and we'll import this from, we'll need to go back to the models folder, and we'll import this from, we need to go back out one directory and then go into the models folder, and then we'll say user schema.js, and I'm going to go ahead and save and just check for any errors that you may have related to the reference to this path. And the way that I want to make use of this now, I want to go ahead and implement a create function here, and this is going to be an arrow function, and I'm going to reference the user dot. And now that we have this user model that we've implemented, like I said, Mongoose creates the schema layer where it's got a whole lot of tools and queries available to us right like out of the box. So this user that we're importing here is an instance of a Mongoose schema, and so we can just reference a create function, which is, this is coming off the Mongoose model, and we're just going to pass through whatever data that we get in our router. So we'll pass in that parameter that comes in, and we'll send it to the user.create, and then we'll pass that through. It's going to end that off with a comma there, and I'm going to hit save. The next step is in our router. We can just go back to our post, and I'm just going to I'm just going to give us some more space to work with here. And now we can reference the user service object, and we want to reference the create. And so this create function needs to take in data. We're just going to get that from the request.body. So we'll say rec.body, and then we'll just pass that through. This user service create function that we've created is going to be an asynchronous function, so we're going to have to handle this with a .then and a .catch. And with the catch, we can just grab a hold of any error that comes through, and then we can just send back a res.status, and we'll say 500, and we'll just put on a JSON object there. We will say message equals error.message. And in the .then, let's just handle that. We'll say user, and then we'll just say res.status 200. So everything went fine there. And then we'll send through the JSON, which would be the user that we get back. So I'm going to go ahead and save this. And because we've now implemented our user service with a .then and a catch, we can just remove this res.send status. And the other thing that we need to do is we need to mark this as async. So just to make sure that we're clear, what we're doing is we're referencing the create function on the user service, and we're passing through whatever data comes on the request body. That function receives the data that comes off our request body, and then it passes it to this instance of user, which is a Mongoose model, and it references a create function on the Mongoose model that passes in the data. And if everything goes correctly, it should then return a user object, which then would be received by the .then block, and then we'll just receive that user and send it back to the client that makes this request. If any error bubbles up, then we'll just send back a 500. So let's go ahead and test this out. The way we're going to do that is we're going to create a request body in Postman that will map to something as what we've created here. So you can just go ahead and create a new tab and make sure it's a post request. You can put in our endpoint here. It'll be localhost:3000 API/user. And in the body section here, you can go ahead and type out your JSON object. To set up this post request with the request body, I think there's an easy way to do this. Instead of typing the whole body out, we can just go File, Import, and there's this option in Postman to paste in a curl, and so I'll just make sure this is available in the description below, and so you can just paste in this curl, and once you've done that and you've imported it, it'll set out the post. You can just make sure it's got this post verb here with the endpoint, and if you go to the body section here, you'll see that it pre-populates this JSON object for you, and so it should have name, first and last name, email, active band, locale, internal, and tags. And so you can go ahead and import that if you want to. Otherwise, you can just type this out in your body as a raw JSON object. But anyway, let's go ahead and hit send here, and you'll see that we get a 200 OK. In our console, we're hitting the post user endpoint. We've got a 200 OK here. You can see that the object has been passed back in the response. And so the last thing that we want to do is validate that this got saved in MongoDB. And so you can just open up Compass and just go ahead and connect to the database connection. And so you go ahead and connect. And then in your My App DB, you'll see that there's a new collection for users, and you should have the exact same information that you sent through. So we can see Peter Parker, the email. The one note to take note of is even though in our schema we haven't defined any ID, by default in Mongoose it auto creates this underscore ID, which gives it an ID for us, and so we're just leveraging the default settings there from Mongoose. And so let's just go ahead and test another user, and then so let's go ahead, let's just clear out the response, and let's go ahead and change this. We can create Tony Stark here, and we'll say Tony@test.com, everything else as it is, and we'll just send this through. We get back a 200, and in MongoDB you can just go ahead and say reload data, and you'll see that we do indeed get a new object that's been saved in here. You can see Tony Stark is in our database. With that code that we've set up, the schema, we've wired it up to our service that uses this create, and then we've wired it up to our router. We've got an endpoint that we can then use to create a user object in our database. So let's take a short break here. In the next one, we'll work on updating our GET request in order to make sure that it's hooked up and wired up to our database. So I'll see you on over there. Cheers. Hello and welcome back. We successfully set up a post request for our user object in the last lesson, and so let's go ahead and start taking a look at our GET request. We kind of just set up a dummy function for us in order to get our API moving forward. So let's go ahead and fix this now. And so the way we're going to do this is we're going to go back to our user service file and just go ahead and remove everything that we've typed there. And with the arrow syntax here, I'm just going to, instead of using curly braces, I'm going to use parentheses because we want that one line return here. Now that we have our user model, we're going to reference the user model, and on the model there's going to be this method that we can make use of called find by ID. And if you want to go ahead and take a look at the docs, you can go to the query section here, and you'll see there's a whole lot of queries that you can make use of here, find by ID. And so this is what we kind of referencing here. There's all these functions that we can make use of on the Mongoose layer, and this just is going to allow us, as I said, Mongoose is going to abstract all that work for us, and it's just going to go ahead and allow us to find an object in our database by using this syntax here. So we'll say user find by ID, and then that'll just be the ID that gets passed in here from our router. And then I'm just going to end this off with a comma just to make sure we get rid of that ID syntax error. And if I hit save here, we just need to go back to our user router now, and we need to do some work to wire up our router to our service. So I'm going to delete all of this from under the ID that we've created. And once we have the ID, we can reference the user service. We'll reference the get, and that's going to take in an ID. And then we'll just handle a dot then by saying user, then we'll say res.status. That'll be a 200. And then we'll just send back a JSON object, which will be the user. And then we'll just implement a catch here to handle any errors, and that'll be res.status, and that'll be 500, it'll be JSON, and we'll just say message will be the error.message. Go ahead and save your work, and let's test to see if we haven't made any mistakes here. And so in Mongo Compass, just make sure you grab a hold of an ID that we can use. So let's do the first one for Peter Parker, and in Postman just go to your GET request and replace the ID with the actual ID of the item that you want to retrieve and paste that in. And then I'm going to hit send here. You're going to see if everything worked correctly, you get back a 200. You'll see all the information that was stored in the database has come through. And the one thing I want you to take note of is, remember, when we were creating the schema, I said any of these things with an underscore. These are things that I only want admins to see. So actually, I would like to strip this off the object that gets sent back, as well as this $_v, which is just something that gets appended here by Mongoose. There's a way that we can do this in our service layer just to ensure that none of this gets sent back. So the way we can do this is with these queries, we can use like a whole chain of methods here, and there is this method here called select. And so when we use the find by ID, it's going to find an object with the ID that we pass through here. And then if it does find it, it's going to then retrieve that object, and it's going to make it available to the next kind of function that we have in the chain here. And so if we use the select method here, we've got the ability then just to return certain fields. And the way this works is that you can set up an array, and then with strings, just reference whichever the keys that you would like to return. So for example, if we just say select email, and if I save my work here, and we go ahead and just hit the GET request, you'll see that we get the ID, which gets sent back by default. And instead of having the whole object, only the email that comes through. So the select method here is a query that will just return specific properties on the object. So that's, you can just pass through a list here of strings that you want. So this syntax with the strings can be a comma separated list, an inclusion list. So whatever you pass in here will be sent back. But they also have this exclusion syntax that you can use. So instead of referencing the properties that you want to be sent back, you can reference the properties that you don't want sent back. And to ensure that it's excluded, you just use this the minus sign, which will basically be like subtracted from, it's like the opposite of select, it's like deselecting it. And then you can just reference the name, and so we want that internal property not to go through, as well as the tags. Just make sure you have that minus and then underscore. And the last one will be that $_v, which we don't want to be. So you can go ahead and save that, and you can just hit send. And you'll see you get back the whole object with all the information you want, minus whatever that you've set out in that exclusion list. So that's pretty cool. I think just to make this a bit neater, we can set up a little property on our object here, and we can move this over to this property here. So that'll be a property on the object that we can make reference to. Just make sure you have your comma there. And so whatever, as if your schema grows or if you add anything to it, you can just list out internal fields. And then in the select here, we can reference user service. So that'll be a reference to this object here. And then we'll say .internal fields. And then let's just go ahead and test that out. You'll see that you get back all the fields minus the ones we don't want. So that's working all good and well. All right. So now that we've got our get route all sorted and working correctly, let's take a short break here. In the next one, we'll turn our attention to the update function. So I'll see you on over there. Cheers. So if we take a closer look at the response that we get from the post request, you'll notice that even though we defined keys for the created and the updated timestamps, there aren't any fields on this property. And if you look closer in the database, you won't see them in there either. And the reason is that in our request that we send through, there is no created or updated fields on here. This is one of the properties on the objects that I don't necessarily want to send through on the request. I actually want the timestamps to be created when the instance is created in our API. And so I want to make use of a cool feature in Mongoose, which allows us to set up our own little pieces of middleware. And the way we can do this is we can reference the user schema that we've created, and we can make use of this pre function here. And this is available to us from the Mongoose model. And it's just a piece of middleware that we can use then to kind of do these kind of things. And what we want to do is programmatically add the created and updated values to the schema. So the way we do this is we can reference a specific query. So on any save that happens, we can just set up a function which will act as our middleware. And this function can optionally take in a next function, which then will just continue down the pipeline of work that needs to be done. And so what we want to do is let's just create a timestamp, and we'll say const now equals date.now, and this should create a timestamp in millisecond. And then let's set up a new constant. We want to say const doc equals this. And this is just going to create a reference to the user model that we're working with. And so that's the instance of the user model. And then because it's the instance, we can reference doc.updated. We're just going to assign that to the value of now. And then we're just going to set up a conditional bit of logic here. I'm going to say if doc.created does not exist, we'll just say doc.created equals the value of now. And then so if there is no created value, we'll just go ahead and create that. And then the last thing to finish this off is we'll just say if there is anything in the next function, then we can just go ahead and execute that. And with that piece of middleware that we've created, we should see that the timestamps that'll be on the request or on the response. So let's go ahead and test that. We can just go ahead and use a new object here. We'll say, just create anything here. We can just say John Smith. Say John and just change that slightly, and then we're just going to go ahead and send. And if you take a closer look at the response that we get back, you'll see that we have the updated and the created fields, and they've been successfully created at the time of that little piece of middleware that's been running. That's just something that we need to implement there, and that's a very cool, handy feature of Mongoose that we can make use of and leverage for these kind of functions that we need to make use of. Hello and welcome back. In the last lesson we set up our post endpoint, and it's working end to end now. This lesson we will focus our attention on updating a user. So let's start off in our user router, and we've created and stubbed out this request handler for the put method. And so I'm just going to go ahead and delete that res.sendStatus, and I'm just going to mark this as asynchronous. And for the put route here, we're going to need to get a hold of the ID. So we'll say const ID equals request, and we'll get a hold of that value from the parameters. And the second thing that's going to come through is we need an object which will contain the data of the information we want to change. So we can just say const data equals request.body. So whatever a JSON object can just be passed through on the request body that will contain the information that needs to be changed. So it'll just be the key value pairs of whatever values need to be changed. And then we can go ahead and we'll reference user service.update, and we'll pass in the ID and the data, and we'll just set up our .then, which would be user. We'll have a user that comes back. We'll say res.status, and that'll be 200. Then we'll send back JSON with the user. And we'll just set up a catch. If anything goes wrong, we'll have an error that comes up, and we'll say res.status is 500. And we'll send back some JSON where we'll say message equals error.message. So we actually need to go ahead into our user service and implement this function here. We've set that up so it takes in an ID and data, and this is going to be an asynchronous function that we're going to use here. So I'll just mark that as async. And I'm just in this function block, I'm going to open it up and set up a try catch block here. So we can set up something to handle any errors that come up while we try and do this operation. And if we do get an error, then we'll just throw the error. And in the try block, what we want to do is we want to return, and then we'll await user service, and then we'll say find by ID and update. So this is a function that's available to us on Mongoose, and this is going to take in the ID. So I'm just going to give us a bit more space here to work with. So it's going to take in an ID and then an object. And this object is going to use the syntax we'd use $set, and that's going to be the key that Mongoose uses to know that it needs to update the information that we pass through here. And so the information that we want to update it with is the data. And the last option that we just want to pass through here is this new. We want to set that to true. And with that, let's just go ahead and test this out. You can go ahead and choose an object from your database. I'm just going to go ahead and use this John Smith object that we've created. So you can go ahead and copy that ID. And if you head on over to Postman, let's just do a GET request. And we can see the information that comes back. Just take a note that the updated and created timestamps are exactly the same. So this object hasn't been changed since it's been updated. And so now let's go ahead and set up our put Postman requests here. So in a new tab, you can just go and choose the put verb and then set up your API/user endpoint, and then just paste in the ID of the object that you want to go ahead and change. You can just set up a JSON object which will contain a JSON object of what you want to change. So we can just go ahead and change name, the last name to test. And so let's go ahead. I'm just going to set this up so that we can view our terminal. And so I'm going to hit send here. And you'll see that we successfully hit our put user endpoint. You'll see that in the response that we get back, the name has been changed. The last name has now been changed to test. But the thing which is challenging and something that we need to overcome here is that it's now also deleted the first name key from here. So what's happened is if we only needed to change the last name and not the first name, we would have to then also pass through an additional key, even though we want to change it just so that it remains the same and so that we can maintain the first and last name. So it's a little bit of an annoyance in terms of having to send this through in the response each and every time. So let's go ahead and write some code that will just be able to sort this out for us. So what we can do is we can set up a conditional here. We can say if data.name, and this is just going to do a check for us to see if there's in the data that wants to be changed, does it contain any first name or last name? And if it does, we want to take this object, which would be data.name. Then we want to loop through each one of the entries. We want to grab a hold of the key and the value. And then once we have a hold of that, I'm just going to give us a bit more space to work with here. Once we have a hold of that, for each one, what we want to do here is kind of flatten this object out. So we'll say data.name, and then we'll do the key, and then that'll equal the value. And so we're moving from a nested object into a flattened object structure. So for every key on that name object, it'll do that. And then the last step here is we want to delete the data.name, and that will delete the whole object. And so we've essentially flattened out the object that's coming in here. And just to kind of see what's going on, we can put a console log here. So we'll take a look at what data looks like at this stage, and we'll reference data there. And then once we've done our little loop, let's take a look what it looks like then. And I see there is an error in our API here. I've just made a very silly syntax error there. And so just make sure that you have data and the square braces on either side of that. And so with that saved, let's go ahead and test this one more time. So I'm going to delete this first name key, and we'll just do another test. And you'll see that we get the object pasted out here. So let's just go ahead and JSON stringify each one of these. All right, and we can do a retest there. And so let's change this back to Smith, and you'll see in our console log, the first data that comes in here is a nested object. The next one is just using this flattened structure which says name.last. And in this way, then the data that we pass through here, the Mongoose will know to only update the name.last property. Update here is working quite neatly. Let's change the first name back to John. Let's go ahead and just maybe change another item here. We'll say johntest2.com and send that through, and you'll see that the email has been updated. We've now got capital John there. So that's all looking good and working well. The very last thing I wanted to do is you can see that the user object that's being returned contains our internal field. So the way that we can fix this is at the end of our find by ID and update, we can just use this select method, and we can just pass in the user service internal fields. And then that's going to make sure that it doesn't send back any of that sensitive information. So if I hit a send here, you'll see we only get the information that we want back. That's all looking good. And there is actually one more thing that I want to do on the update here. If you take a look at the created and the updated timestamps, you'll see though, even though we've changed the information on this object, the timestamp for updated hasn't been updated. So let's go ahead to our user schema, and let's implement a little bit of middleware here. So we'll say user schema.pre. So I want to activate this piece of middleware whenever the find one and update query is activated. And so we can just set up a middleware function here, and we can just reference this .set. We're going to use the updated key here, and we're just going to set that to date.now. And then very simply, we can just, if there is a next function, we can just pass that on. So that's pretty simple. We can go ahead and test this out in Postman. So if I hit send here, you'll see that there's a new timestamp now that's been updated. So every time we make an update to our object in our database, we'll know when the last time it was updated. And I think that's it for our update method and our endpoint. It's working well for now. Let's take a short break here. In the next lesson, we'll finish off by implementing the delete function. So I'll see you on over there. Cheers. The very last endpoint that we need to take care of here is the delete endpoint in our API. And so let's get started straight away. We can delete this res.sendStatus. And we can just get a reference to the ID of the user that we want to delete. So we'll say const ID equals rec.params ._ID. Then we'll just reference the user service. This is something we haven't created yet, but we'll implement a delete function. And that'll just take in an ID. And I want to implement the dot then a little bit differently here. So we'll just open up a function body here. And we'll say if there is a user object that's passed back, we'll say res.status, and that'll be at 200. And we'll say .json. We'll just say message. So user with ID has been deleted. Otherwise, in the else condition here, if there is no user that's passed back, what that means is that we get a user not found error. So we'll say 404 here. We'll say res.status is 404, and then we'll just say message, say user with not found. And then lastly, in the catch block, we'll just handle that as always, and we'll say res.status is 500, and we'll pass back some JSON, say message, and then error.message. So with that, we have got our router set up with some basic handling. And now we actually just need to go ahead and implement this delete function. So in our user service, you can just go ahead and create a new key on this object, and we'll just have this delete key. And this is going to be a very simple one-liner here, similar to the create. We're going to make a reference to the user model, and there's this function that we can make use of. It'll say find by ID and delete. Then that will just be an ID that gets passed through from our router. That's all that we need to implement in our service. Quite simple and easy. So let's go ahead and test this out in Postman. Well, first off, just choose an item you want to delete. Let's go ahead and delete these items that don't have any timestamps on them. So I'm going to select this Peter Parker object. In Postman, you can just go ahead and open up a new tab, create a delete method here. Just reference your API/user, and then just paste in the ID that you want to delete. Let's go ahead and hit send, and you'll see that we get back a 200 with a message user with this ID has been deleted. And if we go back to our database and we reload the data, you'll see that Peter Parker has been deleted. And let's go ahead and delete the Tony Stark item. So I'm going to paste that in and click send, and we can see the user has been deleted. We can go reload our data, and you can see we've only got one object in our database now. And let's just see what happens if we pass in an ID that doesn't exist. So you can just go ahead and change the value, just make sure it's like the last digit, because we want to maintain the type of object ID. And you can click send there, and you'll see you get this message with user with this ID is not found, and we get back a 404. So if you see this error where it says cast object failed, it's just the length of the ID that you passed in there doesn't match what is required for a Mongo to try and find the ID in the database. So just make sure it's the exact same length as a normal ID. And with that, we've finished our delete endpoint. So now it's working end to end, and we've successfully in this module created a post, a get, a put, and a delete. And so our API is starting to grow, it's starting to build, it's starting to be able to produce something a bit more functional. And I hope you can see the value of using Mongoose here, as well as MongoDB. Being able to make use and leverage these schemas are super helpful and make it a lot easier to work with MongoDB like this. So that's a wrap for this module. We've done a lot of work. Well done on making it this far. In the last module, we're just going to set up some error handling as well as some validation on some of our endpoints just to make our API a bit more robust. So I'll see you on in the next module. Cheers for now. Hello and welcome to module 10. In this module, we're going to take a look at setting up some validation on our user schema. In the last module, we wrote a lot of code to set up our our user endpoint in our API. While we did do a lot of work in those previous lessons, there's still quite a bit that we need to do to get our API handling errors in a more elegant way, and also ensuring that the request or the data that is coming through the API is good quality and in line with what we actually want to store into the database. Before we start implementing the validation in our API, let's just take a look at what we're trying to achieve in this module. So running through these objectives real quick here, we want to ensure that we implement some basic Mongoose schema validation, as well as look into how we can implement some custom validation logic leveraging Mongoose onto our user schema. In terms of our own user model, we want to ensure that the name and the email properties are required, and that we actually enforce some rules on the name and email attributes in terms of making sure only valid names and valid email addresses are saved. We also want to implement a npm package into the API called validate.js, and this is going to help us implement our custom validation logic. And then lastly, we want to make sure that our error handling in terms of the request that gets sent back if there is data that doesn't meet our validation logic is working in a better way. We're going to start looking at introducing some new error codes into our API. Instead of the basic 500, we want to start introducing some 400 payload error codes in. This is what we're setting out to achieve in module 10. In the next lesson, we're going to get started and working through this step by step. So I'll see you on over there. Cheers for now. Now that our API has a user endpoint that has 4 methods available to us, we've got the create, which is a post, got a get, a delete, and a put method. So I'm really happy with the progress we made, and the API is starting to take shape. The problem and the issue that I have at this point in time is that basically any data that we pass through from the client, so in our case we're using Postman, whether this data is good data or bad data, our API doesn't really care. It's just saving it into the Mongo database anyway. And to demonstrate this, let's work in Postman, and we'll send a few requests here, and then we'll also just take a look at Compass and take a peek at what's actually being stored in the database. Before we start sending these requests, obviously just make sure you've got your Docker containers up and running, and just make sure that the MongoDB has been started and the Express API is listening at port 3000. And if you're ready to go, before we save anything to the database, let's just take a quick look and see what's in there at the moment. My current instance of the database has just got one user object stored in here. It's got an email of john@test2.com. In terms of the first name and last name, it's just John Smith here. You can go ahead and delete some records out of your database by selecting the document and just saying remove here. Otherwise, if you change the view into a table kind of view, there's also a delete button here. Go ahead and sort your database how you want to. I just want to have one record in there. If we head back to Postman, I'm just going to use the same data here that we have on our request payload. And the first thing I want to try and do is I'm just going to remove this whole email attribute from this payload. So I'm just going to delete that. I'm going to go ahead and send, and you'll see we get back a status 200 OK. We get a response back from our API back in Mongo Compass. If you just refresh the database, you'll see that we do get a second document that has been stored in there now, and you'll see in the email field or attribute there is a no field here, and so basically that's a null value that's been stored in there. And so even though the email property wasn't even on the request payload, that data has been saved to the database. And for a second test, we can just clear this response. Let's just put that email key or property back onto the request payload, and let's just send in a value that we wouldn't typically expect to be in this email field. In our schema, we've defined this as a string, and so let's just put a number in here, and obviously this is not a valid email address in any shape or form. But if we send this through, we get a 200 OK back. And the interesting thing to take note of here, in the response object that comes back, we'll see that this email property that we sent through, so it has been returned from the API. And you'll see that the value of this email property is a string, so it matches the exact value that we passed through here. However, it looks like it's been converted to a string. And if we inspect that in the database, we can just go and refresh. And I'm just going to use this table view. We can see a third record has been stored into the database. And in the email field here, you'll see that we have this 182012, which is the number that we've passed through. You can see that it is a string indeed here. So that just proves that information is being stored into the database. The last test that I wanted to do is if we take a look at this first record in the database, the email address is john@test2.com. It's very common in databases and with the user models especially, is we don't want duplicate email addresses. We want this to be a unique value in the database. So let's go ahead back to Postman. Let's just change that the value of the email back to john@test2.com. So that matches the email address of that first record. And if we go ahead and send this through, we get our 200 response back. And in the email field over here, we've got this value, john@test2.com. Back in Mongo Compass, we can refresh our database. We see a fourth record that's been stored, and we see the email address is john@test2.com, and that matches pretty much exactly what's in this first record. And so there's duplicate data that has been stored into our database, which is obviously problematic for what we want to achieve within the design of our system. The short, quick demonstration is just showing us that basically we've got an open pipeline from the client all the way through to the database, and whatever we're sending here in Postman is just being dumped into the database, and this is just not robust. It's not what we want. And so this is what the whole module is about, is we're going to implement some logic into our API, and it's going to what we call validation logic, and this is just going to ensure that the incoming request is inspected and it gets rejected at some point within the request response lifecycle if our API detects that the data that's being sent through is not what should be saved to the database. So we basically need to just tell our API if that payload kind of meets our expectations, and if it does meet our expectations of what we want, then it may save it into the database. So we know that 100% that we need to implement this validation logic. I think the question here is, where exactly are we going to write it? And there are a few ways to go about doing this. As always, there's no one solution that fits every design. With software development, there's many different ways that we can solve these kinds of problems. And each solution that we implement or each design decision that we make has some pros and some cons. So we'll just take a step back, have a look at a high-level diagram, understand how our API is structured so far, and then I'll walk you through and explain my thinking in terms of where I want to put the validation. And hopefully this gives you a rock-solid understanding before we start writing code, and by the end of the module, everything will kind of just fit and click into place. But as always, if you have any questions or comments, or if any suggestions on how you would do something like this, just leave a comment in the question and answer section and we can discuss that. Even as a student of this course, maybe just follow along with what I'm doing, implement it the way I've done it, but then just explore different ways and then kind of rip it apart, break it to pieces and implement it and test different variations of this validation for yourself. I've tried to introduce a few different ways of doing this just to get the juices flowing and allowing you as the student just to learn a different way of doing this. And that just adds more to your skill set and to your knowledge base. The more you get exposed to these type of things, I think the better developer you're going to become. So enough waffling on about that. Let's just take a look at the slide and try and answer this question. Where exactly do we want to do the request validation? This little circle here represents our Express API, and we can think of this as the outward facing interface that our API is between the client and our backend, and our backend is all the code that we've written as well as our database. So we have our Express API which listens on port 3000, and it's waiting for incoming HTTP requests from any type of client. And just to highlight the specific parts of our API that are important in our thinking here is we've obviously set up our router, which is well designed and nicely broken up to have a router instance for each type of endpoint that we have, like high level endpoints. So we have a user router for all the user endpoints that our API will have. And specifically on the validation logic, we're going to be working with the post request a lot in this module, because that's the HTTP endpoint that we are using to actually save data into our database. And obviously there's the most validation is going to be required on this endpoint. Each router has a service layer kind of linked to it and hiding one level beneath it or next to it, however you want to think about that. And so each request handler that we set up in our router will reference the user service, and then there's different methods there. And so the post request will use the user service.create. And that method is going to take any data from the router, and then it's going to trigger this create function, which triggers a save in the database. But the way this works is that there's a third layer beneath and linked to the service layer, which is our schema layer or our model layer. And this is where the user schema was defined. And so these are the three moving parts of our API and the three parts that any incoming request has to make it through in order to get to that database. So to have a visual representation of this, we have a post request, which we initiate in Postman, but you can easily do this via curl, or otherwise if we built a front-end application, like a web application or mobile app, whatever makes that request we'll refer to as the client. But anyway, we have this incoming request which gets sent to port 3000, and so for our user endpoint it'll be whatever the host is. In our case it's localhost 3000 /API/user, and that request is going to hit our API, and then that request is going to then be routed through our API. It's going to get matched to the post request handler, which is linked to the user create. So once we're at the level of MongoDB, which is the database layer, the user service create will trigger a save to MongoDB, and so a save operation will occur. The data will be saved into MongoDB, and then once that promise has been returned from MongoDB, that promise gets returned kind of up the chain. So like from the schema layer, which is the Mongoose driver, in our service layer, we just kind of pipe that back straight back to the request handler, which initiated this kind of asynchronous request. And then once it either catches it in a catch block or in the try block of our promise chain, it'll make use of the res.send and send a status with a payload back to whichever client initiated the request. That client will then receive the response object however we've set that up in our request handler. So these are the main moving parts of our API, how we've kind of coded and designed our API to use these three layers. And so the question is, where do we do the validation? Do we do it on the router layer, the service layer, or the model layer? And the short answer is that we could actually add the validation in any one of these layers, so that at any one point in time, let's say in the router layer, if we inspect our request that comes in, we could reject it right then and there, and it won't ever make it through to the service layer. Or we could allow the request to go through to the service layer, rejected in the service layer in the method that we have there, then return or throw an error, and that will send it back to the router layer to send it back to the client. Or we could allow it to go all the way to the model layer, reject it there, and then send it back to the client. In a way, these three layers can act as gatekeepers. Whenever it detects that a request is invalid or the format's not correct, it's just going to then reject that promise that's been set up in the request handler, and it'll never allow it to actually send it to the database, and therefore our database kind of like stays clean and neat. And so you can think of each three of these layers as gatekeepers that we kind of need to get through in order to reach our database. So like I said, technically we can implement it at each layer. I think the things that we need to think about here is avoiding duplicating our efforts. So we don't write duplicate validation in each layer. That's just going to make work hard for ourselves. From a code cleanliness point of view, we want to make sure that we're not polluting the router or the service layer too much. The third question to ask is, does Mongoose, which is our database driver, contain all the necessary code that we need to implement this validation, just to make our lives a bit easier? So the end goal of our validation is that upstream of our Mongo database layer, we just want to prevent bad or badly formatted data from being stored into the database. So we never want to let a bad request ever reach the database layer. And taking those 3 points that I mentioned into account, by the end of the course we'll actually have some validation in the router, but majority of our validation is going to be on the model layer, and this will be done at the schema level, and we're going to take advantage of Mongoose and everything that it provides for us out of the box. We've explained why we need validation, and we've taken a look at how we're going to do it. So that's a wrap for this lesson. In the next lesson we'll start looking at Mongoose and take a look at the docs and see how we can start implementing some of this validation. So I'll see you on in the next lesson, where we'll start taking a look. At the end of last lesson, we started talking about how we're going to do the bulk of our validation at the model layer of our application. We're going to leverage some of the code that's already available to us via the Mongoose package that we've used as a database driver in our API. If we head on over to mongoosejs.com and we go ahead to the schema section here, this is something that we've implemented in the previous module. The one thing I wanted to show you here is this title, for example, uses the shorthand syntax where the Mongo type string is assigned to it. There is this longer syntax where you assign an object, and then in that object you can have a whole lot of different options. Within that object and the different options that are available to us, there are validation options that we can pass when we kind of using the longhand syntax. So if you head on over to the validation section, you can take a read through here. And the first point I wanted to point out here is this first point where it says the validation is defined in the schema type, and that the validation is run as a middleware. So we did some work with the middleware where we used a hook on the save to do some of our own kind of custom timestamp logic that we've implemented there. But the point here is that on our schema definition, we can include some validation, and behind the scenes, Mongoose is going to run that validation on the save hook, so just before it's saved. And if you take a look at one of the code examples here, you'll see that on this schema here, where it has a name attribute, it's using the longhand syntax here. It's it's declaring a type, which is a string. And they've now declared a second attribute here, which they make use of this required, and then they're setting that to true. And if we scroll a bit further down, you'll see that this required validator is part of the built-in validators from Mongoose. Every schema type has the required validator that we can make use of, as well as some of the other types have different built-in validators. The number type will have this min and max function or validator that you can use, and strings have enums, match, min length, and max length. To test this out, let's just go and implement the required field in our API. So if we open Visual Studio Code, let's just go ahead and work within the user schema at the email key level. Let's go ahead and remove this shorthand syntax that we're using and open up the longhand syntax. So we'll set the value of email to an object there. We'll just declare a type here. And we'll set that to string. Then we'll just introduce the second attribute here, and that'll be required, and we'll set that to the Boolean value of true. Then I'm just going to go ahead and save our work. And once NodeMon has refreshed our work and restarted the API, we can take a quick look at our database and refresh it. There's 4 values within this database now. And back in Postman, what I'm going to do is I'm just going to remove this email key here, or this email property in the payload. And then I'm going to go ahead and we'll just click send there. And now that we see, instead of the status code being a 200 OK, we get a 500 internal server error with this response with a message which says the user validation failed. The email path email is required. And so at the response level, we can see that this is good news. We're getting a better response back, but let's just make sure it wasn't saved in the database. So if we head back to Compass and refresh, you'll see that we've still only got 4 properties here, and that user without an email has not been saved. So you can see here, just by adding one attribute to our schema, how we can add this validation to our API. Just to be clear here, what happens in the background is Mongoose receives that request. When it tries to run the save function to save it to database, runs this validation, it detects that the email attribute is required, and on the incoming request there is no email coming through. And so at this level, it then will throw an error, which will then return back to this create function that we have here, which will then in turn return it back to the request handler, which will then catch that rejected promise, which has thrown an error. It'll send back this JSON object with a message and the error message that it receives. So this error message that we're seeing in Postman is actually coming from the Mongoose database drivers package. So that's this message that we see here printed out. So that's our first bit of validation that we've implemented. And let's start thinking about how we can prevent a duplicate email from being saved into our database. If we go back to the Mongoose docs and we scroll down in the validation section, you'll see that there's a section with a heading, the unique option is not a validator. At a high level, unique attribute just prevents us from storing duplicate data in the database. So it won't allow the document to be saved if there is a document already in the database with the same value that we've marked as unique. The one thing to take note of here is just this point that they're saying is, even though we set it up like a validator, it's not actually a validator. It's just a convenient way for helping us build indexes and unique indexes in our MongoDB. So all that you need to know is that it just behaves slightly differently, but it's still going to achieve the job for us. The way that it acts differently is in the way it returns the messages, and we'll implement some error handling in our API just to kind of account for that. Long story short, we can go ahead and use this unique attribute and to implement this in our API. So all we need to do is, on our user schema level, we can just set this attribute. We can say unique, and we'll set that to true, and go ahead and save your work. And now the interesting thing that I want to show you here is that, as mentioned in the document, this unique attribute, which is available to us in Mongoose, is actually just a high level abstraction, which behind the scenes, what's happening is a unique index that is created in the Mongo database. If we go back to MongoDB and you take a look at our database, you'll see we've got this tab for documents, aggregation, schema, indexes, and validation. And if you head on over to the indexes tab here, you'll see that there's already one index existing, and this index exists on the ID property. Indexes are set up and used to create efficient querying of documents. So the ID is obviously one that comes out the box and which is set up with Mongoose. And all that means is that we can then search through the database for a unique ID. And Mongo knows that each ID should be unique, and it just makes it easier to search for unique documents. And what's going to happen when we've marked this as unique, it's going to go ahead and create a second index on our users collection for the email property or the email attribute. But the one tricky thing here is that in order for this to happen, I'm going to demonstrate this to you, is that in order for this schema update to be applied with the unique property, we're going to have to restart MongoDB and drop the collection and just rebuild and re-add the collection just so that that schema update can be applied. And this is just something that we need to do for the specific unique property. Like we saw with the required, we just typed it in here. A refresh of our API was enough to include these changes. With the unique attribute and the way that the index needs to be built behind the scenes, it just requires an update and a restart of Mongo. So just to demo this and prove that it's not working, we can just look at our database, make sure we've refreshed it here. We've got 4 records. Let's go ahead and send John a test 2. And so in our minds, this request should be rejected. But if I hit send here, you'll see that we do get back a 200 OK. The response has got the email. If we refresh MongoDB, there's a 5th object, there's a 5th document that's been stored. And we can see there's 3 emails of the same type or same value here. If we head on over to indexes, there's no index here, even if we refresh. Because there was already existing values in the email fields here, we're going to have to just reset our MongoDB and make sure that this new schema is applied. So the first thing I'm going to do is I'm just going to go ahead and right click on those 3 dots and say drop collection. And I'm just going to confirm this, and because we're in a development environment, this is all fine. We're just testing all of this out. So I'm going to drop the collection and you'll see that all that data has been saved and there's no user collection, and that's all good. And then I'm just going to disconnect from MongoDB. And if we head on over to Docker Desktop Hub, we can go to our containers. Then all we need to do is just stop our container. And this is just a high-level container, so it's from Docker Compose. We're stopping all the services that are related to this node Docker Mongo container. And once it's stopped, you should see that the MongoDB has been shut down, but the API is still running, and that's because we've marked this as it should always restart. If you remember back in our Docker Compose file, in our Mongo service, we set restart to only restart unless it was stopped, and in this case, we specifically stopped our container, so it hasn't restarted. But the API, the restart key is set to always. So even though we stopped the container, it automatically restarted because that's how we configured it. So what we'll do is let's just clear the terminal of the MongoDB. Now let's go ahead and restart the container. And once it's restarted, let's go to the API service and restart that. Once the API has been restarted, I'm going to just go into our console logs here and I'm going to do a search for index. And I'm just going to go all the way down to the latest logs. And if we take a look at the MongoDB logs, you'll see that there's some information and printouts related to indexes here, and you'll see, just out of interest, you don't need to go searching for this yourself, but there is this create indexes key here where it says users and it's got unique and it's set to true now, and the key is on the email key. So in our logs, we can see that that index has been built. In Mongo Compass, we can just reconnect to our database. Just make sure that you have all the correct information. So we can go ahead and connect, and you'll see in our My App DB, we've got a users collection, which is empty at the moment. But if we head on over to the indexes tab here, you'll see that there, in addition to the ID index, there's now also an email index. And so technically, if we try and save a duplicate email, it should not work. So let's go ahead and test that out. In our terminal, you can see our logs, they were exited when we were stopping and restarting the container. So I'm just going to rerun Docker Compose logs-f just to make sure we have our API logs or our API console or terminal running out there. And back in Postman, I'm just going to clear this response. Let's go ahead and just save a new document to the database. And so we'll just have the email here is john@test.com. We'll send that through. You'll see we get back a 200 OK. In our documents tab of our users collection, if we refresh, you'll see that we get a document with john@test.com. So that's been saved into the database. And now let's do one final test here. Let's go and just leave it as it is because we want to try save the same user with the same email. And if I hit send here, you'll see we get back a 500 internal server error, and then our error message that comes up here is that we get this code 11100 duplicate key collection on the users collection. The index for email has picked up a duplicate key and the value is john@test.com. So with that one line of code, now API is going to prevent saving duplicate email addresses. That was just a little bit of an explanation because this unique attribute has got a little bit more going on in the background. So just if it's not working on your end and you have set this to true, just make sure that you've restarted it. You've restarted Mongo. You've dropped that collection. You've restarted Mongo as well as the API, and so that new schema has been run and that index has been created. So back to the Mongoose documentation, we've taken a look at unique option here. And if we scroll down a little bit further, we'll see that there's a section for custom validators. And there's a specific reason I want to set up custom validation here. Even though our API is now checking to see if the email key and value pair is on the request, and as well as if the value of email is unique and that there's no other duplicates in the database, there is still some issues with our email validation. And to demonstrate this, let's just put a new email address in here, and then I'm just going to say invalid email. And logically or practically, we know that an email address should include an @, and this doesn't. So if we send this through, you're going to see if we hit send here, we do get a 200 OK, and this has been saved to the database. If we take a look at our data, we can see that we've got this email address, and this email address is absolutely useless because it doesn't have an @. And basically what's happening here is in our schema, we've declared the type as string here. The required is true, unique is true, but we need to do a little bit more validation. We need our schema to pick up whether this is a valid email address or not. And so Mongoose allows us to set up these custom validators where it's saying if the built-in validators are not enough, we can define our own validators to suit our needs. And this is exactly what we need in our use case here. And if we take a closer look at the documentation, you can see that the way we can set this up is using this validate key over here. And this is basically an object, allows us to pass in a validator and a message, and these both can be functions. Basically, the validator function is going to be the function that takes in the value of the attribute we want to test, and it's going to do some logical or comparisons against a test that we create. It's going to then either return true or false based on whether the validation passed or not. And then based on that, this message function will be fired, and it'll send back an error message if the validation failed. If we head back to Visual Studio Code, we can get started working on this. To implement our custom validator, we can just use that information we got from the docs. And so we're going to use this validate option here. And this is going to be an object, and it's going to have two keys. The first key will be validator, which will be a function. So we can just set up an empty arrow function there. The second key on this object will be the message, and that'll also be an arrow function which we can set up. And so these are two functions: the validator, which runs the logic to test the email that's coming through, and then the message is if the validator fails, it's going to receive information from this validate function, and it allows us to return a string back up to the catch block of our request handler. So the way this validator function works is it allows us to grab a hold of the email by setting up an argument here. So we can name this whatever we want. We could name this test, whatever, but let's just match it to the value of the name of the attribute that we're trying to test here. And so we'll grab a hold of the email, and let's just set up a console log, string interpolation here, and we'll say validating email. And we'll just print out the value of email. That's all I'm going to add for now. The second thing is in our message here, I'm also going to add a console log. And the way this message works is it receives this value of props. So if you take a look at the documentation, the message function here receives props, which comes from the output of this validate function. And so let's just take a look and set this up. So we'll say validation failed for, and we'll just JSON stringify this props to see what's in that object. And just a spelling mistake there, it should be validation failed. So the reason I'm saying validation failed is that this message function should only ever fire if this validator fails. So let's just go ahead and save our work. So working in Postman now, we've got this old payload that we've used here. And technically, if we send this through, it should throw a duplicate key error. But what we're looking for is we just want to see our console logs coming out here to confirm whether we've wired up our validation functions correctly. So I'm going to go ahead and hit send there. And you'll see that we do get the duplicate key error. And even though we've hit that error, you'll see that we've got this console log saying validating email. And we see the value of it, which has come through here. It says invalidemail.com. And so that is a confirmation to us that our validator function is now wired up correctly, and we're grabbing a hold of the email. So now that we have a hold of that, we can actually do some logic to test it. So to do that, we can create a comment here, add validation logic to test email. And then the last thing is we need to return a Boolean whether email is valid or not. So the way that we can do that is we can create a constant here. We'll say constant is valid. We'll just assign that to the value of a regular expression that we're going to set up here. Basically, we just want to do a couple of basic tests here. We want to see if there's an @ sign and if there's a period. So we're going to make use of a regular expression here. And really, we're not going to get into the syntax of these things. It's a very weird topic to go through, but just make sure that you follow along and copy the regular expression that I have here and type it out exactly as we've got it. So I'll have a /. We'll open up a pair of square brackets and we'll use this caret sign, and then we'll reference the @ sign here. Next up comes the plus sign, and then right after that will be the @ sign. We'll open up another pair of square brackets and we'll use this caret sign again. And then this time we'll have a \, and then right after that will be a period or a dot, and another plus sign. After that will be a \, and then we'll reference 2 periods, another plus sign, and lastly we will have a /. So that will be the regular expression. And then in JavaScript we can use this test function. So we'll say .test, and then we'll pass in the value of email. And so basically this function is going to take in the email, it's going to run this regular expression on it, and then it's going to return either true or false whether this test passed or not. And then it'll assign it to the value of is valid. And so let's just do a console log here to check the progress of our regular expression there. And so we'll just print out is valid, and we'll just leave it like this for now. So we're just taking this one step at a time. You can head back to Postman and we can trigger a send again, and in the console logs we get our first console log validating email, and we can see we've got invalidemail.com, and then we see the value of is valid is false, and so our code is telling us that this is not a valid email. And this is great because we are missing the @ sign. So let's just run a few more tests. Let's include an @ sign, but remove the period there from the .com. And if I hit that through, you'll see that we have the @ sign without the period in it though, and it's still false. And let's say that I just change this back and make it a correctly formatted email address. And if I hit send here, and in this case with invalid@email.com, we get back the value is valid is true. And so that's kind of what we're looking for. We've run through all those cases. So we have some very basic lightweight validation running here. So what we need to do now to kind of finish the validator section here is we can just return is valid. I'm going to go ahead and save our work, and I'm going to hit send. So we'll just keep the same email address, invalid@email.com. I'm going to hit send here and we get the duplicate key error. But even though that error prevented us from saving it, we still get is valid is true. So in this case, the message function has not been fired yet because it only fires when we return false from the validator function. Let's go and mock that up now. So let's just put in an invalid email address, and I'm going to go ahead and send. This is exciting because this is what we're kind of trying to build up towards and understand this step by step. So if we walk through this step by step in our console log here, you'll see that this first console log, when we've run the case with invalid email, sits here. And then our second console log, we can see over here it says is valid is false, and then we return false from this validator function. This message function then will be triggered. It will receive the props, and then we can see that with this console log over here, this last one where it says validation failed. And we've dumped out that object, and we can see there's a type here key where it says it's a user-defined error. User-defined error means that it's an error that we've checked for and set up in our custom validation. The path here is email, so that is related to this email key over here. And then the value is actually the value that has been sent through in the request. So now we've got the validator and the message function working. The last thing that we need to do is just with the message function, we actually just need to return an error here. We'll just set up some string interpolation, and we'll just reference props. We'll want to grab a hold of the value from there, which would be the value of the incoming email. And then we'll just say is not a valid email address. And then you can go ahead and save your work. Back in Postman, we can test this out. And if I hit send here, you'll see we get a 500 internal server error. But more importantly, we can see that in the response object that's sent back, we have invalid is not a valid email address. And that proves to us that we are then successfully returning this error message back up the promise chain, and our response is then sending that back to the client. So we've successfully set up our custom validation logic on the scheme at the schema level. I think let's take a short break here and we'll continue work in the next lesson. I'll see you on over there. Cheers for now. Now that we have our custom validation logic set up, I want to implement one more improvement into our code here. Up until now, we've only been working with the email attribute, and there's some specific things that we want to test for in terms of validating the email that's coming in. Stuff like whether it's a valid email, there's a duplicate, and stuff like that. And so in the last lesson, we wrote the code to implement some of our own lightweight validation logic. And the improvement I want to make is I want to leverage an NPM package called validate.js. What this is going to do is it's going to allow us to have a much more powerful set of options in terms of validation. And so when we're working with other attributes in our database that needs more complex tests and logic to determine if they're valid or not, we can leverage this package. And it's also going to help us make our code a lot cleaner, which will come in a few steps time. For now, we can just head over to validatejs.org and you can take a look at the documentation. You can read this and just get more familiar with it. Just like the very short version here is that this is a very, very well used, well designed package that is available to us and it is production ready. We're going to go ahead and install this in our API. And the whole idea with validate.js is that it works with this idea of constraints. A constraint we want to implement on a piece of data to say that it should or should not be a certain way. The format and the way this thing works is it has each constraint has an attribute and it uses this nested object syntax in order to work, but we'll go through that in a moment. The first step is that we actually need to install this new package. So remember that in order to install the package, we are going to have to stop our API. So in Docker Desktop, we can just go ahead and stop the container that's running here. And once the container has stopped running and it's exited, we can just clear this to give us some more space. And we just want to change directory into the API folder. And at the API level, we're going to do an npm install validate.js. I'm going to hit enter and let that save. Once the package has been saved, in our package.json, we can just check and ensure that it's been installed, and we can see the validate.js package has been installed there. So back in our terminal, we can just make sure that we change directory back to the parent folder, which is the root directory of our project. And then I just want to run a Docker compose, and then I want to rebuild the API image. So I'm going to run that command. Once it's been rebuilt, we can just go ahead and do a Docker compose up and then -d just to not have the logs. And the last step is I want to run Docker compose logs to ensure that we can see our API log. Before we start writing the code, let's walk through a very detailed explanation of how exactly validate.js works. And very specifically, if you take a look at the documentation, you'll see under the validate function heading or section, there's the single value validation. So if we just go ahead and look at this, this is the specific function we want to use from validate.js. And the reason why is that this single function, as the name suggests, allows us to test a single attribute. So this is a specific part of validate that we're going to make use of. And so taking a walkthrough of how this works behind the scenes is just going to help us understand the code that we're about to write. How exactly does validate.js work? Here's a small example of a code snippet. We have validate.single, and it's got two arguments that it takes in, the email and the constraints. So the email would be the value of the piece of data we want to be testing. And so in our case, we've been working with this email address that's coming in from our API request. The value of email that gets passed in, the email argument will be the value john@test.com. And then the second argument here is the constraints. And it's an object that contains a list of tests that we want to run on this first argument that we're passing in. And so once this validate.single function is run, the output of the function is going to be one of two things. If the validate package has run those constraints you passed in and it picks up any errors, so if any of the validation has failed, it's going to return an object where it's going to have the structure of, for the attribute that you test, it'll create a key called email in our case. And then it's going to just list out an array of strings. And then it's just going to create a list of aggregated errors for each constraint that failed. So this is important. And we'll get to this shortly when we write the code. Just remember that when the validation fails, it returns an object. And when the validation passes, it returns undefined. When the result of the validate.single function returns undefined, it means that there was no error that was picked up, and so that the validation has passed. And just kind of give you a conceptual understanding of the way this might be working under the hood. So we have a little piece of code here where we're going to import the validate package. We've got our email and our constraints, constants that we create. And then obviously we're going to create our own constants, like whether an email is valid. And we're going to invoke the function validate.single. We're going to pass in those emails and the constraints. And then just to kind of walk through the logic of how this is working behind the scenes. And this is just a representation of what might be happening, but just this gives you an idea of how this is working. Validate is going to create like some type of variable, maybe called errors, and it's just going to initially declare it or assign the value of undefined. And then it's going to then run through a kind of logical flow of all constraints that we pass through, and it's going to run these tests. So in our case, we've got two constraints that we pass through. We're checking presence, whether the value is actually there, And the second one is whether it's a valid email. So as we invoke this function, it's going to run through this conditional flow. And let's just pretend, I know it says john@test.com, it's a valid email address there, but let's just pretend this is the case for it being an invalid email. So it will test whether it's an email is present, and if it's not a valid email, and then what will happen here is that it's going to add an error in the form of a string, and it's going to then override the value of undefined and now set it to an object, and it's going to set that email key with an array. And that array is going to contain the first error that is picked up from this first constraint. Then it moves on to the second constraint, which is checking if it's a valid email address. So it's going to test whether it's a valid email address. And let's say that it's not a valid email address. Because that test failed, it's going to push an additional string into that error message there. So that array will contain two errors then. And then there's no more constraints to run here. And so then once it's finished running through all the constraints, it's going to then return the errors that is picked up. It will then return that error object that it created, which contains that email key with all the string errors that it picked up. And so the value then will be truthy because it is an object. So the value of is email valid is going to be that object that was created, even though the validation failed. So all we need to do is we're going to need to reverse the logic, but I'll explain this when we write the code. But just for now, just remember that when the validation fails, an object's returned, and that just makes whatever's being returned from it truthy in nature. And then let's just go through the example of a positive test case. So it'll go in the case of a valid email address, it's going to check is the email present. It's going to run to that first constraint, and that's going to be yes. And so you can see that the errors that we have here, it's still undefined, nothing's been added there. And then it's going to say, is the email a valid email address? There's still no error, so the value of errors is still undefined. And then it's going to return this errors variable. It's going to return undefined to is email valid. In this case, even though the validation passed, the value of is email valid is going to be undefined, the way that we've set this up. But I'm just explaining to you how this works, because there's just one gotcha that we need to work through here. And so all that we'll need to do is we can change the name of a variable to is email not valid, or is email invalid, or we can just reverse the logic of the value that's returned from this function. Back in Visual Studio Code, we can get to work here. And the first thing we're going to do is import the validate package. So we'll say import validate from validate.js. Then once we have that, instead of this regular expression that we used here, we can just reference the validate package. We'll use that single function. And then this, remember, it takes in two arguments. The first one will be the email, and the second one will be a list of constraints. So let's just go ahead and write this inline for now. We'll abstract it a bit later. We'll give the first constraint present to make sure that it is present. So we'll say allow empty is false. And this is just the syntax that validate uses to test for whether this email exists or not on the incoming request. And the second one is we want this to check if it's of type email. All right, and then we're just going to keep everything as it is. Another reminder, the validate.single function is going to return undefined if the validation passes, and it's going to return an object with errors if it fails. And that just creates a problem for us with the way we've structured our logic. To show you exactly what I mean here is if we go back to Postman and we pass in an invalid email address, so this should technically fail. If I hit send here, you'll see that we'd get a 200 OK back. And if we take a look at the logs and just compare it to the code we wrote, so we see this first console log come through here, validating email, and then we see the second console log and it says is valid, and you'll see that we get back, it says is not a valid email. And the reason why we got a 200 is because the value of is valid here is truthy in nature, it's a string. And so it doesn't trigger this message, which would throw an error. So in this case, it just allowed the email to be saved. So all we need to do is reverse the logic, and we can use the bang operator or an exclamation point here just to kind of reverse the logic of here. And so remember, we've got two cases. If the validation failed, we've got an object with some strings in it. Otherwise, we get undefined, which means it passed. So just to double check this, you can just use a browser to do this where there's a JavaScript runtime. Let's just declare a constant here, and we'll say is valid, and we'll assign this the value of an object. And we'll say email, and then we'll just give that a test here. If you hit enter to save that into the memory, we can print out is valid here. And then what we want to do is we'll just use this bang operator and we'll say is valid. And you'll see that if we use the bang operator here, we get back the value of false. And this will just allow us to return false to trigger that the validation has failed. We can just clear this out, we can set this up again. We'll say const is valid. and we'll just assign some type of string. We'll say it's not a valid email. And then if I use the exclamation point and say is valid here, you'll see that we still get false back here. Okay, so that's for the case for when we get any type of errors that have been picked up and we want to send through false. The last thing here is let's test the positive case. So remember, in the positive case, constant valid is going to be the value of undefined. So if I reverse the logic here, you'll see that we get back true. So if we receive undefined and we reverse that logic, it will be true and will allow us to save to the database. We can just make sure we save our work here and we can go ahead and test this. If I run the same invalid email com, and if I hit send here, you'll see that we do indeed get a 500 internal error. That message is triggered and the error is thrown. We can see now we've set up validate correctly. Let's just go ahead and put a correct email, and let's just finally put something. We'll say steve@accounting.com, and we'll send that through, and you'll see because that's a valid email address, we get back at 200, and even though the value of is valid is undefined. So I hope that all makes a lot of sense. Let's just go ahead and clean up this code a bit. The first thing I want to do is remove the constraints that we've defined in line here and move that to the top of the file. So we can do that by declaring a constant here. We're going to call this constraints. So the idea with this object is that we'll have a key for every one of the proper attributes of our schema. So down the line, if we wanted to set up constraints for the name, we could just assign that to the key. And then we're just going to use arrow functions here to return an object of the constraints. And so once you've set up that function, you can just go ahead and copy the contents of the original object that we've set up there, and then we'll just then set up this return with an object and then copy those two constraints in, and we can make this a bit more concise. Instead of returning the object explicitly, we can use some shorthand syntax here. So I'm going to remove this return keyword, and then I'm going to remove all the space so that this can now be moved one line up, and then instead of wrapping this with curly braces, we can use the parentheses syntax here to just do a one-line return. And I'll just delete this space. I'll just format this nicely, and now that looks nice and concise, and that should return this object with the two constraints. We can just then remove this object from our second argument there and just reference constraints.email, and let's just go ahead and test to see if this is working and we haven't made any mistakes. And so just set up an email address and make sure that it's an invalid one, and we'll hit send here, and you'll see we still get our console logs. It looks like our validation is still working. It caught this error for us. So the next step to make this clean and neat is let's just go ahead and remove all the comments and the console logs so that we're left with these 2 lines of code. We can make this neater by doing a one-line return here. So I'm going to remove this return bang is invalid, and we can just remove the constant declaration. We can just do a one-line return here, and just remember to reverse the logic and make sure your bang operator is still there. That's really important. And we can take this one step further and just do a one-line return on this whole function so that it's just one line of code, and remove that semicolon. And we can also just remove these parentheses because there is only one argument here. I'm going to go ahead and save our work, and let's just do a real quick test. Let's send through this request with an invalid email, and we get it's not a valid email address. Our validation is still working. We can see the message from the console log from the message block is still being printed out there. And so we can do the same thing here. We can remove this console log. Instead of explicitly returning, we can just do a one-line return. We can remove that curly brace and the semicolon, and as well as the parentheses here. And with that, we've kind of got a very neat way, a much neater way of adding custom validation by defining the constraints here and making use of some ES6 JavaScript syntax. We've just got one-line functions that we can make use of here. And let's just go do one final test. So the negative case, we still get it rejecting it because it's invalid. And let's just put in a valid email address here and hit send, and we do get a 200. So everything is working fine. All right, done some great work here. Our custom validation is implemented with nice, neat, concise syntax. We've also got this constraints object, which now we can leverage and add any constraints for any of the other keys that we want to implement some custom validation on. Let's take a short break here. In the next lesson, we'll pick this up. So I'll see you on over there. Cheers for now. Hello and welcome back. We've now successfully implemented validation on our schema, and we're working with this emailer property. Let's go ahead and implement some more validation, and let's work with the name property now. And so originally we defined this name with the longhand syntax in Mongoose, where we declared the type, and we said that this object must have a first and a last. We go ahead to Postman and just test this out. I'm just going to put a new set of email here. I'm just going to say test@test1.com. For the first and last name, you can see, let's just for the first name put some random numbers and some special characters here. And if we send this through, you'll see that we get a 200. The first name that comes back is exactly what we've sent through. If you take a look at Mongo Compass, and if we go to the document here right to the bottom and we expand the name object, you'll see that this name is stored here. It is a string, but it is like, this is not a valid name. It's not really what we would expect to be a typical value for a name. So what we want to do is we want to lock down our API and ensure that any names that are saved, they must only be alphabetical characters, so no numbers or special characters. Now that we got all the pieces set up for our validation, and we know how to do it, we can kind of just implement the code and fly through this real quick. And the first step is I just want to go ahead and remove everything that's within this name object here that we declared previously. And then we're just going to change it up. With nested objects, we can use the syntax where it's just the outer key, which would be name, so it'll be name.first, and then that we can just open up an object for that. We can do the same for last. We can just declare the Mongoose types here. So we'll say this should be a string, and then we can go ahead and use our required keyword, and we want to set this to true. One point I wanted to make here is that in order for custom validation to actually work, for this validate function to actually work, you do need to mark the attribute as required. So if you don't include the required keyword, the validate functions will never run. So we've set that up for the first. For the last, we can just do the exact same thing. We can say required is true. Now I'm going to go ahead and save. We can test this out in Postman. Let's just go ahead and remove the first key altogether. I see that we get user validation failed. Path name.first is required, so that's great. And just undo that last one and remove the first. And you can see we do get an error here. So back in Visual Studio Code, the next thing we want to do is we've marked this as required, and now so we want to implement our custom validation, and so we can set this up using the validate key. We'll open up that object and we'll set up the validator function. And in this case, we're going to grab a hold of the name property that's coming through, and we'll just call this name. You could call this first or name. I'm just going to go ahead and call this name because it's the same thing really. So just the outer attribute, that name that I'm really cared about here. We can say, we can open up this function. We're using the shorthand syntax here, and then we're going to remember to use the bang operator to reverse the logic of the output of our validate. So we'll say validate.single, and we'll pass in the name that comes through. So in this case, it'll be the name.first, and then we'll need to set up some constraints. So we'll say constraints.name, even though we haven't set this up yet. We'll do that in a moment. Let's just set up our validation here. And for the message key, we'll grab a hold of those props. We'll use some string interpolation. We'll say props.value, and we're going to say it's not a valid first name. Go ahead and save your work. And now let's just implement the constraint. So in the constraints object at the top of the file, right after the email key, we can just open a new key and a function that then will return some constraints. And this is where we can write the constraints for our name. So basically, we want to make sure that the value of name that comes through is only alphabetical characters. And so we can make use of a regex pattern to test the string that comes through and ensure that there's only alphabetical characters in there. So if you go to the validate.js docs and you go down to this section with validators, and there's the section format, the format validator that it has will allow us to do some testing using a regular expression. If we take a look at this code example, we can see that the way we set this up is with the format key here, and then it'll just take in a pattern, which would be the regex, and then this flag, which says I, and then optionally it has a message as well that you can append. So back in Visual Studio Code under the constraints, let's just go ahead and set up a regex here. We'll say regex, const regex equals, and this will be some type of regex. We'll set that up in a moment. The next one is I'm just going to set up a temporary variable here. We'll call this constraints, and we'll open up an object. The first constraint is present, so this is required. So we'll just say allow empty, and we'll set that to false. The next constraint will be, this should be of type string. Next up, we'll use this format validator that we just took a look at. And so this will be an object where the pattern key will be the regex that we pass through here. And it does take in those flags, and that's just some configuration for how the default behavior should work. And we'll just go according to the documentation. We'll pass in the flags and it'll be a string with the value I. I'll just fix that. And then lastly, we just want to make sure we return this whole constraints object. Because we're doing a bit more work here, we can't use the single line return, but that's all fine. The last thing we need to do is just implement this regex here. And again, let's just type this out slowly. So we'll have a square bracket with a backslash, then we'll put a dash, another backslash, a single apostrophe, and a capital A and to Z. And so we just want to include capitals as well as any lowercase, so it can be lowercase or uppercase. Then we'll just put in a space here, and then we'll put a square bracket, have a plus sign. And so this is just going to say it should only be alphabetical letters, lowercase or uppercase. So let's go ahead and save our work. We do reference constraints.name here already. So let's go see if everything's working as expected. We've been sending through this first name with these characters and it's been saving to the database. Now, if we go and send the same thing through, we're going to get this user validation failed. We can say name.first is not a valid first name, and so that we know that our validation is now working for first name. All right, so the last step then is just to implement this custom validation for our last name. This is going to be exactly the same thing, so I'm just going to go ahead and copy this. And in the last section here, we'll copy this validate function. Everything is going to be exactly the same, except for this just little string here. So it's going to say is not a valid last name. And let's go ahead and test this out. So I'll just put a valid value for the first name, and it's going to say, we'll just say John there, and then for the last name we'll just put in some weird characters. We'll hit a send, and we'll see that the validation fails, name.last, and it says whatever we pass through here is not a valid last name. Then one last test, let's test the positive case, and we'll just change the email to a second one there, hit send, and we get a 200 back. So that's working well. We've implemented the validation on our email and our name attributes of our Mongo schema in a nice, concise way. For this course, that's all the validation that we're going to implement. You can go ahead and test this out with some of the other keys and go play around with this. But for now, we've got the mechanism set up. I've shown you how to do that. We've got validation sitting at this high level. So let's take a short break here. There's one last bit of work that I want to do back in the request handler, and then we'll wrap up this module. But I'll see you in the next lesson where we'll do that work. So cheers for now. Hello and welcome back. The last lesson of this module, we're going to turn our attention to the request handler, which is in the user router of our API. And now that we've implemented the validation on the model layer, we've set up the validation on the schema level to throw errors under the hood, and it's sending these messages back to the user router. And so we've taken a look at this, but what's happening is basically the way we've set up this user service.create, it sets up a promise, and whenever there's an error that it picks up this error in the catch block, and then it returns a 500. And the problem that I have with this is that a 500 error, usually that will be for something that goes really wrong inside of our code. So if it failed to the database because the connection's not alive, or there's an error in our code, that's when you would generally trigger a 500 error. The new validation work that we've passed in and the errors that we're getting from that, I wouldn't call these 500 errors. I would call these 400 payload errors. And so basically we're saying that the request payload is causing the problem. It's not the code of our API. Back in Postman, if we simulate this, send a bad last name there, you see we get back that 500. I want to be sending back a 400 instead. In your user router, make sure you're in the post request handler. So we've set up this user service.create. It uses a promise, and whenever the validation or anything else throws an error, this catch block will catch any of those errors. It will then send back a 500 with some JSON and the actual error message that is received. So to get started on this, what I want to do is I want to unwrap this catch block. So what I mean by that is we can just go ahead and highlight this or select this piece of code here and just cut that out. We'll open up a set of curly braces and give us some space to work with, just to kind of unwrap that function body. And then we can go ahead and paste the line of code you cut out, the res.status, and paste that in at the bottom of the function block. And we just need to add the return keyword here, just because we were using the shorthand syntax one line return, but now we just need to make sure we return that. And before we do anything else, I just want to do a console log here. I want to inspect what's going on in these errors. So let's say user post error. Let's just JSON stringify whatever comes back through that error. I'm going to go ahead and save our work here. And there's a few different cases that I want to work with. And so I'm going to just leave the first and last names correct here. I'm going to clear out the response. And I want to work with this email key because there's two different types of errors that we receive. So let's simulate an error where the key is not present. So this should trigger either the Mongo schema error that we've got for the required, or else our custom validation where it says the present should not be allowed to be empty. So just go ahead and send that through. You'll see we get back a 500, and you'll see our console log that we get here that we've typed out. We get back this object, and just to inspect this object in a bit of a neater way, I'm going to copy that from our terminal. So just like the outer object here. And I'm just going to go ahead and use this tool called JSON Crack. And this is just a cool online tool that you can use to inspect JSON. I'll paste in that object that I've copied there. And you can just paste that into this pane here, and then you'll see that it formats it nicely, and in addition to that, it gives you a nice visual way to inspect this whole object. So if we take a look at the object here, we've got this outer key here, which is errors. So this errors object then will contain an object with a key and object for each one of the errors that it picks up. So in this case, all these errors are related to the email attribute, and then this email error then gives us some more information. We see that this is a validation error. It's got some other properties and some messages that we can make use of. So that's one type of error. Let's just go ahead and add that email key back here. And if I simulate an error where it's a badly formatted email, so I'll just remove the @ sign, and if I click send, I'm going to copy this error back into our tool that we're using. I'm going to paste that in, and you'll see it's the exact same structure here. It's just different values. You can see it's not a valid email address. The third one I wanted to check here is the duplicate key error. And so we set this up to say test@test2.com, and just make sure this is an email address that already exists in the database. And I'm going to hit send here. You'll see we get this duplicate key error 500. The object looks a lot different. So let's take a look at that in this tool that we're using. And you can see that this object looks really different. We have just one object with an index code, a key pattern, and the key value. So the reason that this is happening is, remember when we're working on the email unique attribute here, or this option that we can put on the schema, this behaves in a very different way. It's not a validator per se. It's the convenience of creating the index behind the scene. All you need to know is that this option throws an error in a different way to the others. So just all that means for us is that we need to handle it in a different way. Back to our user router, we're going to have to set up some conditional logic just to check for these different cases. I want to design this catch block in a way where I want to catch all the 400 type errors first. So I'll just put a comment here, and we'll just say catch the 400 type errors first. And the way we're going to do this is just use this error. We'll use the error argument that we get back from the catch block, and we'll just do some checking to see what type of error it is. And if it is a 400, let's return a 400 instead of a 500. And so I'm going to just, the way we're designing this is we're going to conditionally go through and check that error as we go down our lines of code here, and then return early out of this catch block if we get a 400. Otherwise, if it doesn't hit any, or if it doesn't meet any of the conditions for 400 error, we'll just use this last line of code as a catch block, and then safely say that, okay, this is a 500 error. We've caught all our payload type errors. Let's implement some code to check for this first one. And let's just say we're going to use this code to check for it explicitly. So we'll just set up a conditional if statement here. We'll say if error.code is triple equal to 111000. So if that is the case, then we can just set a res.status. We'll set that to 400. Then we'll just send back some JSON, and we'll use the same kind of structure that we have been using. We'll send through a message, and we'll just say user with, and then we want to grab a hold of the value of the email. We'll say user with email already exists, and we can get the email from this key value.email path in the object. So we'll say error.keyValue.email, and then after the res.status, we need to write this return keyword. And this is what this return is going to do is it's going to return out of the whole catch block. So it's going to make sure that we don't ever hit this line of code. So let's save our work and test that out real quick. We're testing the duplicate key error here. So this test2.com is in the database. I hit send there, and now I get back a 400 bad request, as well as a neater error that we get back here where we've got more control now. Instead of sending whatever we're getting back from Mongoose, we now can send through some nicely formatted errors on our side. So that is the case for the duplicate. So I'll just leave a comment here. I'll say check for duplicate key error because that's a specific type of error we want to check for. And the next one is just validation errors that we pick up. So let's go ahead and write that code. So we can open up a conditional if statement here. We can say error.name. So if we take a look at this structure of this object on the like first level of this object, we can just check for this name, and if it's a validation error, that's what we can use. So to know that this is just a general validation error, so we can say if error.name is triple equal to validation error, then we'll open up a function block there. We can decide what we want to return back. Previously we were just sending back this error, but it's not really nicely formatted. I think if we take a look here, the messages that are on the level of the attribute look a bit better, a bit nicely formatted. But the problem we're going to face here is that we need to write a very generic function here that is able to get into the errors and then .email, but we can't write code for checking every attribute in our schema. That's not going to work really well. So we need a more generic approach here. And so the other thing I want to show you is that if there's multiple errors on different parts of the schema, it's going to be listed out in this object. So at this point in time, we just have an email with the errors related to the email. But let's go ahead and include some errors on the first name. And so we can simulate that. And then we go ahead and, well, I'm going to copy this object just so that we can inspect this. And you can see in this case, we have errors name.first. And if we try and simulate another error, so we can, in addition to the first name error, we can put in an email address there and send that through. Now, if I copy this object, it's going to contain two errors that relate to two different keys. So I'm going to paste that in, and now you can see what I'm talking about here. We've got a block here for the name.first errors and an additional block for all the errors related to the email. Even though all the information we need here, we want to grab a hold of this message. We could have multiple validation errors that we need to send back. In our code here, we just need to account for this. Basically, we just need to capture a whole lot of different messages that come through. So we're going to set up a constant, and we're going to call this constant messages. And I'm going to use the object.values syntax here. And basically, I want to get all the values for each one of the items in this object. So we'll say object.values, and then we'll say error.errors. So that's the outer object key here. And then we can set up a map, and we're going to use this map to transform and basically grab a hold of each one of these message properties here. So I'm just going to create our temporary variable there for the map function syntax. And then we'll say e.message. We're just going to then do a res.status. We'll say 400, and then we'll send back some JSON with the message. We can just say messages, and then we can use this JavaScript function for join. And using this syntax with a comma and a space, it's then going to create a string out of each one of the error messages that we get back. Just remember to implement your return there. Once you've saved your work, we can go ahead and test this. You'll see that we get a 400 now with a string that contains a comma separated list of our errors that we do get there. All right, so that's a wrap for this lesson as well as the module. We've done some really great work to get this validation sorted. Our API is definitely starting to take shape now, and there's one last module in this course where in the next lesson we'll just implement some better and more elegant error handling. So well done on making it this far. I think it's been really good so far. So I look forward to working through that last module with you. I'll see you on over there. Cheers for now. Hello and welcome to module 11, the last module of the course. There's just a final bit of work that we want to do to get our API to the point where we're going to call it a wrap for this course. So as always, let's just take a quick look first at what we want to try achieve in this module. This whole module is going to be dedicated to improving our error handling, and specifically the errors that our API return to the client. I want this to be in a nice structured, formatted way. And this is going to make work on the front end a lot easier, and also just give us a bit more structure to our error responses in general throughout our API. So we're going to go ahead and we're going to create a base error class, and then we're going to extend that base class with two different types of errors. For now, we're going to do internal errors and payload errors, but the base class will then allow us to extend it with any other errors such as authentication and any other type of errors we want to include in our API. Once we've got those classes set up, we'll go ahead and refactor the catch blocks to make use of those error classes. We'll make sure that all the errors are handled elegantly. The last piece of little validation onto our user routes, and that's just going to make sure that we sending through valid IDs. So we'll get started with this in the next lesson. I'll see you on over there. Cheers for now. Before we start writing the code to make these improvements, let's just take a look at what we trying to achieve. So I've got this little diagram here just to explain what we're trying to do. This is the end goal or the end result of the code that we're going to write in throughout this module. When we make an API request, I want this object to be sent back to the client. And this object's going to have an outer error key. On that error, we'll have an object that will contain all the error details. And this is just going to make it a lot easier to work within the front end, because then we can just kind of reference res.error and we'll have access to all the information related to the error from a specific API request. I want to include this property on the object called type, and that's just going to denote whether it's a payload error, an authentication error, an internal error. And then we'll include a timestamp, and this is going to be useful for logging purposes. We'll introduce a key for the actual code, which will be a number. An important change I want to make here is, at the moment we're just returning a message with the error. I want to improve this slightly, and the messages key, I want the value to be an array of strings so that we can have multiple errors if they do come through. And with that being an array, it'll make it super easy to work with on the front end. And then lastly, we'll have a property called key. And this key property will just relate to which specific attribute on the schema is giving the issue. And then lastly, we'll have a key on the object called service, and that will just relate to high level service is causing this issue. In this case, we only have the user service, but down the line, when you implement more logic into your API, then you can just label whatever the service name is and assign that value to this key. So if your API is running and your Docker containers are all set up, back in Postman, we can just send a request just to double check where we are. We're getting the correct code coming through. And as you can see, the object that we get back, or the JSON that we get back here, is not in that structure that we want. So back in Visual Studio Code, we're going to be working with the post request again. But before we start working in the user router, we're going to go ahead and add a new folder to our API. And this is going to be dedicated to any logic or code that we write related to error handling. And the reason I want to do that is, if you take a look at the root handlers, you'll see that wherever we send a response.status and we send back JSON, this happens multiple times in the user router. This happens in every request handler. And sometimes it's going to happen multiple times even within a request handler. And so I just want to have a nice clean way of constructing these objects that get sent back to the client. So let's go ahead and start working on this right away. In the source folder of your API, we're just going to create a new folder. We're going to call this errors. Within this folder, we're going to create two files. The first one will be the index.js file. The second one will be a file that's going to be called errors. And because this is going to contain classes, I'm just going to give this an uppercase E for errors. So that'll be errors with an uppercase E.js. So we've created this index.js file, but we'll come back to this in a moment once we've got something to import and export. In our errors.js file, we want to set this up using a base class, and then we'll have specific classes that extend the base class, so that we can have any attributes that are unique to all errors can sit in the base class, and then any properties or attributes that are specific to different types of errors then can sit in the extended instance of those classes. So for now, we've only got two types of errors in our API. We've got this payload error, which is the 400, and then we've got that internal error, which will be a 500 error. And so for now, those are the only errors that we're going to work with. But before we implement those, let's start with our base class. We'll use that class keyword, and then we'll create a class named base error, and then we'll just open that up. And in the base error, we're just going to set up a constructor. This constructor is going to take in one argument, and it's going to be the type of error that we can pass in when this class is initialized. We're just going to default that to null. And then in the constructor, we will then create some keys on the class, and we'll say this.error, and we'll open up an object. This object is going to have a type, which will be the type that comes in from the constructor. And because this is all named the same thing, we can just make use of some a shorthand syntax there to name the key and the value the same thing. And then the last attribute here that's going to be unique to all errors is a timestamp that I want to set up. So we can just use date.now, and this will give us a timestamp in milliseconds. And for now, that's all I want to do in the constructor of our base class. Right underneath the base error, let's go ahead and create our two different types of errors. We're going to have a payload error. So we'll say class payload error. And then this is going to extend the base error class. We are going to eventually export this payload error, so I'm just going to use that export keyword, and we'll set up a constructor And for now, it'll just be an empty constructor. And in the constructor, all we want to do is invoke the constructor of the parent class. So we'll just say super and then invoke that. We will just pass in, because this constructor takes in a type, we'll just pass in the type as payload over here as a string. We'll just go ahead and create the same thing for our internal errors. So we'll say export class internal error, and then that extends the base error class. And in the same way, for now, implement a constructor. We'll just invoke the constructor from the parent class with the type being internal as a string. Right, so we've scaffolded out the classes that we want. At this point in time, these objects will only ever have a type and a timestamp. We haven't implemented anything in the specific classes that extend the base error, but let's just set up our errors so that we can export them. So in the index.js file, we can just go ahead and do a one-line export here, and we can export the payload error as well as the internal error. And that'll be from the errors.js file, which is in the same directory that we're currently working in. So I'm going to go ahead and save. Right about now, let's go ahead and just wire this up to our user router and see if we can get it working in a very simple way before we start adding more code. So if we head on back over to the user router, and at the top of the file, we can import these two classes. So it'll be the payload error class as well as the internal error. We need to go back one directory and then into the errors folder. And then we're going to reference the index.js there. I'm going to hit save. Let's go ahead and start using this right now. So in our post request handler, wherever we see our 400 statuses that are being returned, let's just go ahead and remove the object that is being sent. For now, all we can say is, or we can instantiate a new instance of the payload error class. And that's all that we need to do for now. And then I'm going to go ahead in that validation error conditional block. We'll do the same thing. We'll do a new payload error, and then we'll just instantiate that class. Lastly, we'll just do the same for the 500. I'm going to remove that object and I'll say new, and then we'll just reference the internal error class, and then we'll instantiate it. And let's save our work, and let's go ahead and test that in Postman. Once we're in Postman, we can just go ahead and send a request that we know will fail. And so I'm going to hit send here, and you can see we get that 500 bad requests coming back. And now we have a much better JSON object that is coming back to us. We've got that outer error key. We've got a type, which we know is a payload type error, as well as a timestamp. So these values are exactly what we see that is coming from our base error. And so that we know that this is all working properly. We've tested the payload error, but we can also just double check and make sure our internal error is working correctly. And we'll just comment out the rest of the code here temporarily, just to make sure we hit this line of code. And then in Postman, we'll hit send, and you'll see that we get a 500 internal server error back, because that's the status that we sent back on the res.status. But we also getting those common properties that we want to send back for all types of errors. We can see that here, and the type here does say internal. We'll just go back and uncomment out this code. The last little change I want to make here is just remove this console log. We don't need it anymore. So I'll just remove that out and save our work. So with all of that work now, we are done for this lesson. Let's take a short break here. In the next lesson, we'll continue on with this work. So I'll see you on over there. Now that we have scaffolded out the classes for our different types of errors, let's continue on with our work. We can head on back over to our errors.js file, which contains all our classes. The base error class looks good, and let's just progress and start working on this payload error. So at the moment, we've set up our constructor and it's not taking any arguments in, and so we can go ahead and we can write some code so that we can expect a few values to come in when this class is instantiated. And these variables are going to be a key, which we'll just set to null here. And then a message, which we'll default all these arguments to null. And the last one that we want there is the service. So we'll say service is null. Now that we have those values, we can start in our extended class here, adding some more properties to that object. So to do that, we can just reference this.error, and this is going to be available to us because we've created it on the base class and we've extended the base class, so we'll have access to this .error object. And then we want to append a new key on there for code, and because this is a payload error, let's set that to 400 and we'll set it to a number. The next key that we want to add here is messages, and we'll just assign the value of messages to whatever gets passed in to the constructor when it's when the class is instantiated. The next key here that we want is this .error, and it's going to be called key, and that'll just be the key that gets passed through in the constructor. And the last one will be this .error.service, and that'll be the service that is passed through in the constructor. And with these few lines of codes, we've now got the whole structure of a payload error kind of as a blueprint. And now we can head back to our user router, and where we instantiate these classes, we can think about how we're going to get the information we need to pass in the values into the constructor. So as of right now, we're not passing anything in. If you do hit a send request in Postman right now, you'll see that we do have all the keys that we're looking for. We have the type, timestamp, code, messages, key, and service, but those three values are null, and that's because we need to grab a hold of that information here in our catch block and then pass that through. So let's go ahead and do the work to do that. And we'll begin working in the catch block that is dedicated to handling the duplicate key error. So first thing is we'll create a constant. And because this is a very specific error that we're catching, all we need to do is we can just assign an array here. And just remember, I want to have an array of message strings. So I'm just going to create an array here with a string. I'm going to use some string interpolation. And I'm just going to say user with, and then we'll pass through the error.keyValue.email just to grab a hold of the value of the email that was passed in. And then we'll just say already exists. Now we have the message. The next thing we need is the key. And if we remember taking a look at the structure of this error that comes back from the duplicate key error, we can get a hold of the key, which we want the key to be email because it's an email error on the email attribute. So we want to grab a hold of this value here. So we can just make use of object.keys. And we want to get that from the error, and then that'll be the key pattern property on that object. Once we have those keys, I just want to reference the first key in there, which we saw was the email. We'll just use this all conditional to ensure that there is a default if we don't find a key pattern on there, because we're kind of indexing into array. We're assuming that that array exists. If anything fails here, we can just have a fallback, and we'll just say email here. And the last thing that we need is the service. And because we're going to be using that key throughout this whole catch block, I'm just going to go ahead and create a variable up here called const service, and we're going to assign that to the value of user, and so that'll be available to us, and it's scoped in this whole catch block so that we can use it in other conditional blocks. So now that we have all this information, we can just go ahead and pass this in. We can see that our payload error class takes in a key, a message, and a service. So we can just go ahead and pass in that key, the message, and the service. We can just double check the order. It's key, message, service. That's fine. And then I'm going to go ahead and hit save there. So let's go ahead and test this out in Postman. So in Postman, just structure a request that you know will fail on the duplicate key error. So just make sure the first name and last name is good, as well as a email address that is valid but is already exists in your database. I'm going to hit send here, and in our response we get our 400, which is good. And now you can see, instead of having those null values, we've got the values that we're looking for. We've got an array with the first message there, the user test2 already exists. So we know that the email property on our request payload is causing the problem, and this is coming from the user server. All right, so back to Visual Studio Code. We can just do some cleanup here. Now we can move on to the validation errors catch block. And these are the errors that are coming from our custom validation or else from the schema validation. All these errors have a similar type object structure that come back from Mongoose. And the one thing that we need to remember here is, as a refresher, just remember that this validation block that we're working with here can have multiple keys on the errors object. So it's going to have an object, a key and an object for every attribute that throws an error. So if we send through a request with a bad first name, it's going to have a whole object block here. And then if there's something wrong with the email, it will also have an error there. So the challenge this creates for us is for the message key that we want to send back. What we need to do is we need to kind of collect and aggregate all the messages from each one of the attributes, then aggregate them into an array, and then send that on. So where we left it in the last lesson, we're kind of just grabbing the messages and converting them into a comma separated string. Let's go ahead and do a console log here again and just take a look at what this messages actually looks like. We'll just print out the messages there, and then we'll also do an additional console log just to see what type this messages variable is. And so we'll just use the type of function there, and then we'll take a look at the messages. and let's go back to Postman and simulate an error with 2 problems on it. So we'll just create a bad first name. In addition to that, let's not trigger the duplicate key error, but rather we'll just remove the @ sign. And so if I hit send here, we can see the console logs that come out here. We have type, which says it's an object, but it's actually an array, and it's 2 strings in here with 2 errors separated by a comma. So this array that comes back is what we can use then to pass through the messages to our payload error. So let's just go ahead and let's rename this to this abbreviated MSG for message, just to conform to how we've been using it. Then we can just go ahead and remove these console logs because we don't need them anymore. And let's go and create our key. And if we go ahead and look at our object here, you can see that we can make use of this path key on this object just to get the name of the key, or we could even use the actual key name itself. We can just do it like this. We're going to say object, and we're going to pass in the error.errors. And if we just do a console log to take a look and see what that looks like, we'll just dump out the key. So if we go ahead and trigger this in our terminal here and we send a post request through, you'll see that we actually have name.first and email. And by simply just getting all the keys on this errors object, we can then pass through that array into the payload. And so with that, we have all of the information we need then to send this through. So as a reminder, we need to send through the key, the message, and the service. And so we'll say key, message, and service. And remember, this service is coming from our high level constant that we've created here. I'm going to go ahead and save my work, head back over to Postman, and let's initiate another bad request. And if you take a look at our response here, you'll see that we have this nice structured error object. The type is a payload. We've got a timestamp, a code. We've got an array of error messages, and we've got an array of keys, which then maps nicely for the first index of each relates to the same error that it is. So name.first will be the first error in this messages index. And lastly, it's coming from the user service. And with that work that we've just implemented, we've now got a nice structured way of sending back payload errors. It's a nice, neat, and very extensible way of setting this up. With this lesson being done, let's take a short break here. In the next one, we'll work on that internal error. So I'll see you on over there. Cheers for now. We've implemented our payload error and we've wired that up to our post request. Let's go ahead and finish implementing the internal error. So back in the error.js file, let's go and move on to this internal error. When this class is instantiated, we're going to expect 2 arguments to come through. The first one will be a message, which we will just default to null, and the second one would be the service that it's coming from, and that will also have a default of null. Following along with the payload, we can just go ahead and add these keys onto the base class's object. So we'll say this.error.code, and this internal error will have a code of 500, and then we'll reference this.error.messages. And our internal error is going to work slightly differently. In our constructor, we're going to initialize this with an array already with 1 string in here already. And so we'll say internal server error. The reason I'm doing this is that depending on what happens with these kind of internal errors, we may not actually get any informative error coming back from the promise or whatever. So I just want to make sure that at the very least, we have a generic internal server error that will always be in this messages array. And then lastly, we'll just say this.error.service, and then that'll be the service that is passed through in the constructor. So now the one question is, we do have an optional message that does come through, and this might be something that happens in the request handler and a message that we might be able to grab a hold of, and that is coming through. And then we need to figure out, because we've set this up with an internal server error when it's initialized, we just have to do this in a slightly different way. So the way we can do this is we can set up a conditional, and we'll say if there is a message, so if that's any type of truthy value that comes through, we can then go ahead and then append that message or the messages that might come through as an array on its own, because it might be multiple messages. We need to process that array or that string that comes through and then add them into this .error.messages array that already exists. So we'll create a specific function to do this. So we'll call this function process messages, and then we'll just pass in the message that's coming in from the constructor. And then what we will do is on the class, we'll create a function called process messages, and that will be an arrow function. And this is going to take in an argument called message. And I'll just leave a comment here. Takes in message, and then this message variable is either a string or an array. So we need to process that accordingly. And so the idea with this function is that it wants to set this .error.messages to an array of all the aggregated messages that come through. So we can say this .errors.messages, and then we'll just assign it to the current value of this .error.messages, and that's because we know that there is an array existing already. But what we'll do is then we'll just use the concat method, and I'm just going to format this in a way that makes it a bit easier for us to work with. So I'll just put this on a new line. So we'll say concat, and I'm going to open up the parentheses here, and then we can just use the syntax here for there's this isArray method on the array prototype, and we can just use a ternary conditional statement here, and we just want to evaluate whether this message that is coming through here, is it an array or a string. And so we'll use this array.isArray prototype method, and we'll pass in the message, and then that's going to either return true if it is an array or false. And so we can say if it is an array in the truthy block of this conditional statement, we can just pass this on into the concat method because it is an array already. And otherwise, if it's not an array, we can simply just use the syntax here to convert it to an array, so that we can make sure that whatever is being passed to this concat is an array. And then basically what the concat method is going to do is it's going to merge these two arrays together. So this existing array that we have already will be merged with whatever array is coming in from our constructor. So that's a little bit more of a involved class, but I think it's going to do the job for us. Let's go ahead and test this out. We can head back to our user router, and we'll go ahead and just comment out the 400 errors, because we just need to simulate a 500. The easiest way to do that is just comment this out for now and ensure that we hit this 500 block. Where we've instantiated the internal error, we can see that this takes in a message and a service. And for the message, let's just send in a string. We'll say failed to create user. For the service, we'll just pass in the service variable that's coming from the top of our catch block. So I'm going to go ahead and save that. We're just going to trigger a request. So I'll go and clear out this response that we had previously. And let's just trigger a request that we know will cause an error. When we test this out, you can see that we do get an error in our Node API. And this is probably a syntax mistake I've made. And you can see it's pointing out that cannot set the properties of undefined. And that's because if we take a look at this line of code here, 43, I've said this.errors.messages, and that's obviously a syntax mistake I've made there. It should just be this.error.messages, and that's my mistake. I'm just going to correct it, save my work. We can go back to Postman, and I'm going to hit send here. Now with that mistake that's fixed, we've got an error which is a 500 error. We've got a type which we can see as internal. We've got the timestamp, a code, and you can see our little bit of logic that we've implemented in that process messages has now inserted that failed to create user string that we passed in, and it's now inserting that into this messages array, and everything looks good for this 500. Great. So back in the user router, we can just uncomment out our code that we had for our 400 errors and save our work. With that internal payload error that we've implemented now, that's the end of this lesson. Let's take a short break here. In the next lesson, we will refactor our other request handlers for the other HTTP verbs, so the put, the delete, and the get, just to make use of the new error handling mechanism. So I'll see you in the next lesson. Cheers for now. Hello and welcome back. In this lesson, we're going to quickly refactor our user router to make sure that all the other request handlers are making use of this new error handling mechanism that we've set up. And so we can just get started and set that up. In the get request handler, all we need to do is update this JSON that we send back here, and we can just say new internal error. And this takes in a message and a service. So the message can just be failed to get user, and then the next argument here will be the service, and we'll just say this is the user service. We'll pass that in as a string, and I'm just going to put this on a new line so that this looks a little bit neater. So we can save our work, head over to Postman, and we can go back and set up a GET request, send through some weird ID to trigger a failure here, and you'll see that upon sending that, we get a 500 back with a nicely structured error, and so our GET request handler has been set up correctly there. We can go ahead and move on to the put and then do the exact same thing. In the JSON here, we can just implement a new internal error, and that will take in a message. So we'll say failed to update user, and the next one will just be the service, and so we can say user there. I'm going to hit save, And I'm just going to make sure I've got my closing parentheses here, which got deleted when I was just updating this. We can test the update in Postman, so we can go create a put request, send through some weird ID to trigger a 500 error. And you'll see if I hit send here, we get our 500 error with a nicely constructed error message. It says failed to update the user. And lastly, in the delete, we can do the same thing. We'll just remove this JSON, open up the parentheses there, and we'll say new internal error. And that's going to take in this message. We'll say failed to delete user. And then lastly, the service will be the user service. And I'm going to save our work. We can go test this delete method, just put in a weird ID, hit send, we get our 500 back with a nicely structured error message, and it's saying it's failed to delete the user. All right, so that's it for that quick refactor. A nice short lesson just to implement the internal errors on the other request handlers. Let's take a short break here. In the next lesson, we'll do one last piece of validation, and then we are done with our API. So I'll see you on over in the next lesson. Cheers for now. In the last lesson, we set up and updated our user router to make sure all our request handlers are making use of the internal error handling class that we've implemented. And if you notice during that testing, and we can trigger that again, let's use the get. If we pass in a bad ID here, we're getting back a 500 internal server error. And that's because we haven't really implemented anything else in those request handlers. And I don't necessarily want to send back a 500 for this type of error. If we send through an ill-formed ID or an ID that doesn't exist, we actually want to send through a different error, and I want to make sure that this is a payload error instead of an internal server error. So if you take a look at our user router, you'll see the get request. It takes in this ID that we get from the parameters. And the same thing for the put and the delete. And so I think it'll be a good idea for us to do some lightweight validation at this stage within our router to actually check if this ID is a valid ID. And there is a nice, easy way for us to do this. We can just get started with this straight away in the request handler for our get request. Right underneath where we grab a hold of the ID that comes from the params, we'll just do some validation to check if the ID is a valid Mongo ID or Mongoose ID. And if you take a look at the Mongoose documentation under schema types here where it talks about object IDs, these are the IDs that are auto-assigned to each one of our schemas that we define in Mongoose. And there is this function that we can make use of here where it's on Mongoose uppercase types and then object ID. With this, there's a method available to us called isValid, and this will determine whether or not this object ID is a valid object ID. All we need to do is we can go ahead and import Mongoose here at the top of our file. And so that'll be import Mongoose from Mongoose. I'm going to go ahead and save our work. Right after we grab a hold of the ID, we can set up a conditional block here. We can say if not mongoose.types.objectID. We can use this isValid method, and then we'll pass in the ID that we get from the parameters, and this will return true or false. So if it is not true, what we want to do is send back a 400 error here. So we'll say res.status 400, and then we'll pass back some JSON. And then we can just say new payload error. Now we have a nice easy way of setting this up. This payload error, if you hover over here, it takes in a key, a message, and a service. So the key here will be ID. We can use _ID just to conform to how it's stored in the database. For the message, we'll just say invalid user ID. And for the service, we'll just reference the user service. So I'm going to go ahead and save that now. There is one last thing right after this res.status. We need to make sure that we return. So we don't want to continue on with anything else. We want to actually exit out of this request handler once we do send this res.status 400. So make sure your returns in there, and we can exit Visual Studio Code and head on over to Postman, and we can just initiate a get request with a bad ID. So we can go ahead and send. And you'll see now instead of getting a 500, we get back a 400 bad request with a timestamp and with a payload error. The message says invalid user ID. It's got a key and in the service it's coming from. All right, so now that we've implemented this in the get request, we can just go ahead and copy this code. So in the put request where we grabbing hold of the ID, we can just paste this block in here that's checking if it's valid, and we can save that there. And then lastly in the delete where we're grabbing hold of the ID, we can just put that same block of code. And so we can go ahead and test this in our put request. Let's try and initiate a send here. You'll see we get back our 400 payload error, so that's good. And in our delete, we get back our 400 and a nicely structured payload error. And with that last piece of work that we've just implemented and tested, we've now implemented our validation and our error handling on our user router. And I'm quite happy with it. Our API is a lot more robust than it was before we set this up. We've got the structure and mechanism set up now to be able to implement these things really easily. The way we set this up with the base classes and classes that can extend, we can go ahead and create any other type of errors that we need to, whether it's a 404 not found error or any other type of errors we want to create. We can just write that class once and then just instantiate it wherever we need it. We've got some lightweight validation on our router layer. We've got some really interesting and custom validation on our schema layer. And so that is a wrap for this module. And so well done on making it this far. That is the end of this course. Thank you for taking the time to go through it. And I hope that you really learned a lot throughout this course.